Python is a high-level, versatile, and interpreted programming language known for its simplicity and readability. It was created by Guido van Rossum and first released in 1991. Python is widely used for various purposes such as machine learning, data analysis, web development, and more. Here are some key characteristics and features of Python. Readability. Python emphasizes clean and readable code, making it easy to understand and maintain. Simplicity. Python's simple and straightforward syntax reduces the learning curve for beginners. Interpreted. Python code is executed directly without the need for compilation, allowing for rapid development and testing. Cross-platform. Python is available on multiple operating systems, ensuring code portability. Standard library. Python includes a rich standard library with pre-built modules for common tasks. Dynamic typing. Python allows variable types to change dynamically during runtime, increasing flexibility. Object-oriented. Python supports object-oriented programming, promoting code organization and reuse. Community. Python has a large and active developer community, providing extensive support and resources. Open source. Python is open source, free to use, and encourages collaborative development. Welcome to aorbtech.
This is an introductory video for Python course, Learn to Python series.
In this series we're going to be covering Python fundamentals from the basics to the advanced, and in this video we're going to be discussing the course outline.
In the first, we will discuss data type and operation, where we will see various data type, for example, integer, string, float, none, and also see some various operation, for example, addition, subtractions, multiplication, and so on.
In the second part of the series, we're going to be covering strings, where we're going to look at string manipulation, concatenation, amongst other things.
And then we will discuss array and tuple, where we will see how we can create an array and tuples. Also, we see our various operations.
After that, we're going to be covering dictionaries and sets, a unique new way of storing your data.
And after that, we will discuss conditional statement, for example, if-else, and case statement.
Shortly after, we'll be covering iterative statements, such as the for loop and the while loop.
And then we will discuss function and recursions.
After that, we're going to be covering file input and output, where we're going to see how to manipulate the files on your computer using Python.
And then we will move forward to object-oriented programming part 1, where we will see a various topic, for example, class, object, class attribute, object attribute, static method, and constructor.
And finally, we're going to be looking at an extended version of object-oriented programming. We're going to take a look at inheritance and some extra special things to help you program very cool objects and classes. So we hope you enjoy this course, and without further ado, let's dive right in.
Hello and welcome to aorbtech. Today we are going to discuss Python second section, and this section is very basic about Python, and I'm going to use VS Code, and VS Code I'm using Jupyter Notebook. The benefit of the Jupyter Notebook is that you can document your code as well, and you will see how I documented this code. So the outline for the today's section is that first we will write our first program using print, then we will see how pip is work, then we will see different modules where we can use in future videos, and in the last we'll see how to write comments in Python. So let's move to first program. So let's write our first program using print. Let's say I wanted to print hello what. So fantastic, as you can see we print our first program using print. Let's say I wanted to add a new cell and I wanted to print something else. Let's say I wanted to print aorbtech. So to print you have to use parentheses, and then you have to use colon, and whatever you write it will be printed. So as you can see we write our first two program. One is we just print hello world, and the second we just print our organization name, which is aorbtech. So yeah, so our second section is about pip. So pip is basically Python package manager which help us to install the packages, and why we're going to use pip. In upcoming videos we will make some videos on Python ecosystem like pandas, numpy, matplotlib, seaborn, and many machine learning libraries. So pip is one of the helper which help us to install the packages. So if I wanted to install pandas is basically data analysis toolkit we will use in future videos. And so let's say I wanted to install packages. Very simple command, pip install pandas, just the name, the package that I wanted to install. So I shift and enter. So it's gonna take time to install the packages. So whatever packages you wanted to use, so just first you need to install and then you can use it. So here you can see this package already installed here, so that's why it's giving the statement that requirement already satisfied. So how the pip is work. So the third section is about modules. Module is basically a file which contain a code which written someone else. So basically there's a two type of module. One is built-in modules which already installed with Python, and the second one is external modules which need to install these external modules to run our program. So let me give a example of external modules. So I wanted to use pandas, which is basically external modules. So for that, first I need to install it, then I need to import, and then after that I can use this modules for that, and built-in modules which already exist. So let me give you example of internal and external modules. Let's say I wanted to give the example of external modules. So let's say I wanted to import OS system, and then I wanted to print the working directory. So let's say os dot stdir. So as you can see, we just import our internal modules to showing our checking our working directories. As you can see, is checking the list of file which contain in this folder. So this is how internal modules is work. Let me give the example of external modules. Let's say I wanted to import external modules. So let's say I wanted to import pandas, which we recently start using pip. So let's say import pandas as pd, and I am going to let's say doing some data analysis. So let's say data frame, let's create a data frame for that first. So pd dot data frame, and I'm going to create one array, 1 2 3. So yeah, as you can see, we import our external modules. For that we need to first install, as we see in pip section, that how we install these packages, and then you have to import these packages, and then you can use whatever you want to do. For example, I import pandas here, and then I create a data frame, and then I just print this data from here. So it's just one column with 3 rows. So this is how external module is work. I hope it will be clear for you. Feel free to write the comments if anything is unclear. I will be pretty sure to help you for that. So in the next one, about commands. So basically commands is very useful. For example, I written a program which is more than 1000 line, and I write some comments. So I send this file to someone else who can check my code. So command, and then he can read the comments to understanding my code. And in Python is basically it automatically ignore this text when using the comments. So it just execute the main code here. So basically there's a two type of comments. One is a single line comments, and the second one is multiple lines comments. So for example, I wanted to say that I import this memories. So I'm going to example for single line comments. So I'm going to using hash to write single line comment. I said that import pandas for data analysis. So yeah, so as you can see, we write our first command. So let's say I wanted to write multiple lines commands. So let's say for using multiple lines command, you can use code. So let's say I wanted to use double line of code. Let's say welcome to aorbtech, and let's say the city, let's Krakow, Poland. So as we can see, we write two commands. So yeah, so that's it for the today videos. So today we discuss print. Let me revise quickly, where we write our first command, then we use pip. As we see that pip is Python package manager to install the packages, and we see how we install the external packages to use our program, and then we see different modules, internal and external modules, and in the end we see comments and how we write the comments. For example, we write single line comment, and we also write double line comments as well, or multiple lines comment. Hello and welcome to aorbtech. Today we're going to discuss continuous series of the Python Learn to Py, and this is our third session about Python. Agenda of today meeting is basically, first we will see what is variable, then we will see different data types. In the third topic we will see different operation like assignment and logical operation. Second last we will see typecasting, where we'll see how we can convert different data types, for example integers to float, float to integers, and so on. And in the last we will see input function, where we will see how our users can provide the input. So let's start. So what is variable? If I explain in a simple word, a variable is basically a container which store a value. So let's say that x is equal to 10. X, basically here we define a variable, and the value 10 we stored in this variable. X is container and the value 10 is stored in this container. Let's take few more example. Let's say that I wanted to take a as a variable, and then I define my value, which is 12. Let's take another example, and I'm going to define another variable which is b, and then I am going to store another string value here. And if I run, and if I define my a, I will get 12. Why? Because I define this 12 value in the variable a, and if I define my b, I will get yo. So this is how we can define our variable. Don't worry about these data types, we will discuss in the next topic. Our next topic is data type, and basically there's a 5 different data types in Python: integers, float, string, boolean, and none. Let me explain with example. Let's say that I wanted to take example of integer. Let's say that I wanted to store integers value in variable a. Let's say that 33, and if I check the type of a, it will return data type. So here we have integers data type. Let's make the example of string, and in a string we, as you know, that we write in the quotes. So whatever we write in the quotes, it will represent as a string. So let's say that we define a variable b, and I am going to store aob as a string, and if I check the type of b, as you can see, it's stored as a string. If you write even numbers inside quote, it will represent a string data type instead of integers. Our next is basically a float, and if I take a variable c, and if I'm going to store a value in points, for example 1.22, and if I check the type of c, it will return as a float. So basically type is a function which gave you the type of the defined variable that I declared here. Our next one is basically a bool. Let's say that variable d, and I'm going to say that true, and if I check the type of d, it will return as a boolean, because true or false is basically represent a boolean values. And our last one is a non-type. So if I write variable e and I define none, and if I check the type of none, it will return non-type. So this is how we can store a different data types, and we can check the type by using this type function. So this is how the data types work. So when you define a variable, there is a certain rule that you need to know. The first rule is basically a variable name can contain alphabet, digits, and underscore. Let me explain with example. Let's say that I made 1 underscore is equal to 1. If I run Amir 1 underscore, it will return 1. So you can have underscore, digits, and alphabet. The second rule is a variable name can only start with alphabet and underscore. So let's say that aob 1 underscore 23. So if I run, it will return 23. So you can start with alphabet or underscore. Let's say that another example, let's say that underscore a is equal to 2, and if I run underscore a, it will return 2. So you can only start with either alphabet or underscore, but in the third rule you cannot start with digits. For example, you cannot say that 2a is equal to 12, and if you run 2a, it will return an invalid decimal literal error. Why? Because you cannot start with the digits. You can start with underscore and alphabet, but you cannot declare your variable with digits. So the fourth rule of the Python is basically no white space is allowed to be used inside a variable name. You cannot make a white space when you define a variable. So for example, you cannot say that a space b is equal to 23, and if you run a space b, you will get invalid syntax, because you cannot make white space when you define a variable. And the last rule of the Python is to make sure that variables is also case sensitive, which means that if you say that capital A is equal to 2 and capital small a is equal to 3, and if you run and if you define a, it will return 2, and if you define a, it will return 3. So these are case sensitive. So these are the basic rule. When you write a bigger program, you need a more defined variable, so make sure you have understanding the basic rule when you define a variable. There is a certain way that you can write variables for better program efficiency and readability. So when you have more than 1000 line of code or even 2000, and when you define a variables, and defining variable is one of the most important key in the program. So if you write your variable better way, it will make understanding for others and for you as well. So most of the program basically follow these three principle. One is camel, the second one is Pascal, and the last one is snake case. Let me give a quick example of a camel case. So in a camel case, you basically write first word with small, and the next word with the first letter capital and the rest of same as second word. So this is the example of camel case, and the next one is basically Pascal. In a Pascal case, you make all words first letter capital if you define a variable. So let me give example quickly. My first code, so here I write my capital first letter and the rest of as same. So let's say that I wanted to define variables, my first code 3. So this is how you can write Pascal case. And the next one, which is my favorite and most of program I use, snack case. So in a snack case, basically you write all of your words basically small, but you between each word you define to write underscore. So let's say that I'm going to write 13 and I define variable 13. So here you can write the snack case in that way. So this is how you can define your variables in that case. Our next topic is operator. Operator is very important topic for today's sessions. Why operator is important, especially when you're working as a data science and dealing data. So you have to apply some filters, and you can apply filters when you know the basic operators in a Python. It's simply mathematics, nothing complex. So I'll discuss one by one. So there's a 4 operators we'll see. The first one is arithmetic operators, and the next one is assignment operators, the third one is comparison operators, and the last one is basically logical operators. So let's start with the arithmetic operator. Now we're going to discuss arithmetic operator. Arithmetic operator is basically a simple math like addition, subtractions, divisions, exponent, and so on. So let's take a few example. Let's say that I want to take as a variable a, and I am going to store a value 3, and I take another variable which is b, and let's say that I want to define a value 2. So in addition you basically add the value. Let's see how I can add this to a and b. So a and b, run it. So it will return 5, as a is equal to 3 and b is equal to 2. So a plus b, 3 plus 2 is 5. The next one is subtraction. Basically you subtract the value. So let's say a minus b, if I run it, it will return 1. Why? Because 3 minus 2, 1. The next one is a multiplications. So let's say a multiply b. For the multiply you can use the star, and if you run it, it's gonna be 6. Next one is exponent. Let me give example. A, for the exponent you have to use double star, and then b. So basically 3 and the power of 3, which is 2, is gonna be 9. Let me give an example of exponent for better understanding. So let's say that 3 underscore 3. So 3 power of 3, which is gonna be 27. So yeah, this is how exponent is work. The last one is basically mode, and for the mode is basically returning the remainder value when we divide. So let's say that a percentage b. So when you wanted to use mode, you have to define a percentage symbol. So 3 divided by 2, remainder is 1. So as you can see, so this is how arithmetic operator is work. Very simple, simple mathematics. So the next one is assignment operators. Assignment operator is used when you assign a values. For example, I wanted to add 4 with these 3 variables. Let's say that add 4. So using assignment operators like plus, equal to, or, and if I return a, it gonna be 7. How? Let me explain further. So here what I did, so basically I take a variable a and I define 3, and then I make addition by using assignment operators. So for example, a plus 4. So this is how I write here by using assignment operator. It's much easier, it's like a more shortcut, instead of writing variable name again and then you can make addition. So by using assignment operator it made more clear. So it's basically used in the loop. We will discuss further in upcoming videos. Let's say that I wanted to subtract. Let's say that c is equal to 2, and I wanted to subtract 2 minus 1. So let's say this c minus equal to 1. So let me give example again, which what I'm doing here. So I'm going to see which is we already have 2 and then minus 1. So if I run this line of code, it will return 1. As you can see, 2 minus 1, which is 1. So this is how you can use assignment operator. You can use some other operations, like for example divisions, multiplications, addition, and so on. So this is how assignment operators work. The next one is basically comparison operators. Comparison operators is very useful actually when we applying some filters, applying some conditions. So it's very handy using those comparison operator. We will apply those conditions. So we have different comparison operator. We will discuss one by one. So let's say that I want to take a variable a and I said that 3. Let's take another variables which is b and I define 2. So let's use first comparison operator which is greater than. So for a greater than, we use a symbol of this one as I write in the bracket, and let's say that I want to say that a greater than b. So it will return boolean values, so which mean that true or false. So as you can see that a 3 b2 3 greater than 2, which means true, so it will return as a true. So the next one that we can say that less than. So same variable values, for example 3 2. So let's say that a less than 2. Does it b, sorry, let's say that, so false, because b 3 is less than 2, which is not correct. That's why it's returned as a false. The next one is basically equal to. So for that you have to write double equal. Let's say that I have a is equal to let's say that 2 equal to 2, so it will return true. So if I say that a equal to b, which is false, as we know that a we have a 3 and b we have a 2, which both are not equal, so that's why it's returned false. Here we said that true, 2 versus 2 is equal to, so that's why it's returned as a true. The next one we'll see the not equal to. So for use not equal to, so for that we have the symbol, this one and this one. Let's say that a not equal to b, and if I return it will true. Why? Because 3 not equal to 2, and which is true. So this is how actually a comparison operator is work. Actually it's very useful, especially when we're using loop or conditional statement, or using some arrays, strings, and applying some conditions. So these are very handy actually in that case. The next one is basically a logical operator. This is basically last operators that we will discuss in these sessions. And a logical operator is basically 3 common logical operators that we will use. One is or, and, or not. So let's take example to understanding better. Let's say that I wanted to a is equal to 2, b is equal to, let's say, 3, let's say another two variables. Let's say that x is equal to 2 and y is equal to 5. So let's run, and let me give example of or logical operators. So let's say that a greater than b or x greater than y. So here we already discuss in a comparison operators, so you are already familiar with that. So what we did here, we said that a greater than b and x greater than y. So a, which is 2 greater than 3, which is false, or x greater than 5, which is also false. So it will return as a false. So if I say that, let me copy and change statement a bit. So let's say that a greater than b, which is false, we already know, but x less than y, so we already, which is already know that 2 less than 5, which is true. So false or true, the return will be true. So false or false, the results will be false. And what we did here, so we said that false or true, the results will be true. So this is how our logical operator is work. So if both are true, it will return true. If one of them is true, it will return true. If both are false, it will return false. So the next one is basically AND operator. So let me explain with example. Let's say that 3 greater than 2 and 2 less than 1. So if I write false and true, the results will be false. Why false? Because in AND they'll make sure that all conditions are true. So if one of them it will be false, it will return as false. Or as we see in OR, here we will, if one condition is true, then it will return as a true. So let me give another example. Let's say that 2 equal to 2 and 3 greater than 2. Here our both condition are true, so it will true results. So as you can see here, so this is how AND operator is work. The next one is basically NOT. So how NOT is work is basically when it's true it will return false, and when it is false it return true. So let's take example. Let's say that not true. Let's say that, so it will return false. Let me give a proper example. Let's say that not 2 greater than 2, and if I run it, what will say that it will be true, because true greater than true is false and false not which is true. So this is how it works. Let me give another example. Let's say that not 2 greater than equal to 2, and if I run it, it will false, because 2 is equal to greater than equal. As you know that 2 either is greater than or equal to 2, which is true because both are equal, and true not which is false. So this is how not operators work. So this is that we discuss very briefly operators. We'll see arithmetic operator, we will check some addition, subtraction, division, then we'll see assignment operators. In the third we will see also comparison operators. We will compare some value and see the output, and in last we will discuss logical operator, which is AND or not. So this is how the operator is work. The next topic about today's session is typecasting. Typecasting is pretty much important when you change the data types. For example, you wanted to convert integers to float or float to integers and so on. So then typecastings will work. We'll see how we can change. Let's say that I wanted to change int to float. So let's take a value in integers. Let's say that I want to take 3, and let me check the type as we know already. But so as you can see, it's integers. So let's convert integers to float. How we can do that? So let's say that a is equal to float, and I will return the value of a, and if I check the type of a, it will return as float. So what we did here, we take the value of integers, we check the type as we already know it's integers, then we convert this integers value into float by using float functions. So as we can see that we just check the type and it's a float. So let me print this value, it will return 2.0 3.0, sorry. So this is how integers to float is work. Let me take another example, which is float to integers. Float to int. So let's say that I wanted to take another value which is 3.2, and I wanted to convert float to integers. So let's say that x is equal to int x, and if I run x here, it will return as a 3 instead of 3.2. Why? Because we changed the type of integers, so it will return only integers value. What we did here, we define a variable x is equal to 3.2, which we already know that is float value. Then we convert this 3.2 into integers. The result is 3, which is integers. So this is how float to integers work. Let me take another example, string to integer or float. So let's say that str to float. For that, there is some valid conditions for that. For example, I have a value in a quotes 3, and I said that I wanted to convert into float. As you know that whatever we write in the quotes, it will return as a string. So let me define you, let me check the type. Let's say that I want to take the type of a, which we already know that string. So we can convert that kind of string into float or integers, because inside quotes it's digits. If it's a character or mixture of character or string, then it will returns invalid errors. So we'll see how it will work. Let's say that I wanted to convert into float, string to float. So let's say that is equal to float, and I will return a, and if I return a, it will return 3.0, because we have a string 3 and we change the data types, string to float, and it will return 3. So let's say if we have 3a, can we change this string into float? That we'll see. So we change or cannot change, you can write in the comments. So in the next 5 seconds, we'll see can we change or not. So let's say that float into a, and if I run, it will throw error, because we cannot convert string to float. So it's valid only if whatever we write in the codes is a digits, then we can change into float or integers. But if we have a mixture like characters, or for example with mixture of digits, then we cannot change. So this is how we can do typecasting. It's very useful actually when you have some cases and some assignments, then you want to change some data types especially you wanted to values only in integers instead of float, and this is how it's work. The next topic for today's session is basically input function. What we do in input function is basically taking the input from the user. So for example, you build a game GT5, and in GT5 what we will do is basically taking the input from the users, for example driving a car, for example catching someone, the riding, and so on. So this is a different way you can provide the input to the program, and program act based on your input. So let's say that I wanted to print my name. Let's say that name is equal to input. You just need input function and then whatever message you want to say. So let's say that enter your name, and I am going to print my name as well. So let's say that I said that Amir Ali. If I run, it will return my name because I provide a user input here, which is my name. So this is how it works. One thing I wanted to mention, if you wanted to check the type, it will return as a string, as I mentioned here. Why? Because when you take input from the user, it will always return a string. So for example, if you need numbers instead of string, then first you need to convert into integers and take an input, and then you can work based on your program. That's how I discussed already in the typecasting. That's it. That was the end of today's sessions. I hope you enjoyed it. Today we discuss variables, and we also see different data types, for example integers, float, string, booleans, and then we also discuss various operations, for example arithmetic, assignment, logical operators, and then we also discuss typecasting, how we change one data type to another using function, for example integers, float, and then we last one that we see how we take input from the user.
Welcome to aorbtech. This is the fourth installment in the Learn to Pi series. Today we'll be discussing strings. Let me go through a brief outline of what we'll be discussing in today's episode. So we'll be looking at syntax, concatenation, slicing, functions, special characters, raw strings, and string interpolation. So let's look at the definition of a string. What is a string? A string is a data type in programming, and as discussed in previous episodes, a data type is essentially the kind of data that the computer stores, and variables can have different data types. So a string is a data type that's commonly used for text in programming, for expressing text and for storing characters. Specifically in Python, a string is an ordered sequence of characters enclosed in quotation marks. What that means is that essentially you have a long list of characters, and they each have their own index, which is a number that's associated with that character in the string. In practice, what this means is that you can have a lot of characters, which are basically just symbols that are represented by a computer. So when you think of a sentence traditionally, each word in that sentence has a letter inside of it. A character is kind of like that letter. But a character can also be a special character, for example, like a space or like a full stop or like a comma or an apostrophe. So characters can be a wide range of different symbols or letters or numbers. So in Python, there are three main ways that you can define a string, and they each have different use cases. So maybe not the most common one, but the first one that you learn is to use single quotation marks. And this is for situations where you just have text. You have text and numbers and maybe some other special characters and some characters that we'll learn about later in this episode. So let's create a variable here. Let's create a string variable. And Python knows that it's a string because you use this syntax. You use these quotation marks. So use single quotation marks, use double quotation marks, and you can use triple quotation marks. And I'll go over which situations you need to use each. So let's create an example string. So this one is going to say hello world. For this example string, We're going to use single quotation marks. So now let's print that, and you'll see that's the result. So you can actually use strings in the print method, and so you can put them in here. In the previous episodes, we used this kind of notation where we would put inside of the print method a string, and that's what would be printed. And this is actually equivalent, this notation is equivalent to this notation, except that whatever value is stored in this variable will be used in this method and will print that text that is in that string. So we have that over there. So let's say that's all cool and interesting, but let's say I want to have another string and I want to describe something else. Let's say I wanna talk about someone's house, for example. So let's have another string here, string 2, let's say, and that's gonna be Eric's house. But then we run into a sort of problem. We use an apostrophe in the string, and the way Python recognizes strings is that there's 2 apostrophes and between them there's some text. But if you have another apostrophe in there, Python kind of doesn't know what to do with that. So the solution to this is to use double quotation marks. And so let me just put those in here, double quotation marks, and then we can now put single quotation marks inside of the string, which is very cool because now I can print that string too, and this is what we get, Eric's house. Very cool. Okay, again, very awesome. But let's say I want to put now double quotation marks inside of the string. Well, okay. So the solution to this, as you might have guessed, is to use triple quotation marks. So let's create another variable, another string. Let's call it string 3. Or maybe let's call it quote, because that's the situation where you'd use double quotation marks the most. So let's have triple quotation marks here. So Python should automatically, or depending on the IDE you're using, or the environment you're using, it should automatically put in the second half of the quotation marks, the closing quotation marks. Now let's put in a quote here. So he said, hello. And then he said it gently. So we'll have that. And then we can print the quote. And as you can see, the output contains double quotation marks. So there are 3 main ways that you can define a string, and they have different use cases depending on if you want to use single quotation marks or even double quotation marks inside of those strings. Another thing I want to look at is a built-in function in Python that allows you to see the data type of a variable. So let's say we define another variable. Let's call it house. And in the house, we'll have some address. Let's just randomly put in some letters. GU23-SW61. So that's a pretend address in a pretend country in a pretend city. And now what we can do is we can actually use the type function, or the type function. And we can put in the house variable. And if we run that, the result is str, and that is what Python represents as a string, is an str. Okay, so let's move on to concatenation. So concatenation in programming is basically when you have 2 strings, 2 or more strings, and you want to have one string from that. So you want to add them kind of together into one string. So let's really quickly just create some code here. So let's say we have 2 different strings. Let's have a prompt. My name is, and then we'll have an answer. Eric. And let's now print prompt plus answer. So it's kind of like adding strings, and we'll see what the result of prompt plus answer is. Now, in concatenation, the order in which you define these does matter. So notice how I put prompt first, and that's this variable here, and then I put answer, which is this variable here. So what we should expect is that this variable, answer, comes after prompt, which in practice means that it'll be more to the right, and you'll see this when I run this code. So my name is, which is the prompt, as we can see, is on the left, and then on the right, Eric, which is the answer variable. So let's maybe look at another example of concatenation. Let's say we have 3 different strings. Let's say we have a string 1, or maybe let's call it variable 1, var1, and that's going to be 12. And this is to show you that characters can be, they don't have to be letters, they don't have to be just things that you would see in a word, or like space, for example. They can also be numbers, and they can be other characters like the @ symbol, or like quotation marks, as we saw earlier, or even asterisk, ampersand, any of those special characters. And we'll look at some more interesting characters later in this episode. So let's say var2 is going to be equal to 6. And you still have to put those in the quotation marks. I'm using the double quotation marks because they deal with that one case where you want to have an apostrophe, and it's not very common that you'll use the triple ones, so that's why I'm using these ones most of the time. Then we'll finally have var3, and var is short for variable, and then we'll have the result of that, of the addition of the first 2 variables, which is 18, in string form, of course. So some mental maths. And what we'll do is now we'll have var4, variable 4, and we'll make it equal to var1 plus, and then we'll have even another piece of text inside some quotation marks, some double quotation marks. So you don't have to use predefined variables. You can also have you can also create variables on the fly. So this would be kind of like, you could imagine it almost as creating a variable on the fly. You're creating a string, basically. So we're going to say variable 4 is equal to variable 1, and then the string plus, so the character plus. Then we're going to have variable 2, and then another plus, equals. And then we'll have variable 3. So what we're basically saying here is that we want to create a variable, which is a string, because we're going to be using strings here. And that's how Python figures it out. So we're creating a variable 4, which is going to be a concatenation of variable 1 on the left side. So this variable first, so 12. And then we want to have the character plus. So that's the symbol plus. And when you do concatenation, it creates one string, right? That's the result of concatenation. Then we're going to have variable 2 added to that, so we're going to have 6. So far we have 12 plus 6, and you can kind of see where this is going. We're going to add another character, equals. So 12 plus 6 equals, and then we're going to add variable 3, which is 18. So now what we can do is we can print variable 4 and see what that looks like. So hopefully the result that we're looking for is that it's going to show us the calculation 12 plus 6 equals 18. So let's see. And that's correct. That's what it shows us. So awesome. Let's move on to the next topic. And the next topic is string slicing. So string slicing, as we mentioned earlier, a string is kind of like a long chain of characters, right? And each has their own, it's in a specific order, right? Let's say you have a sentence. If each word was in an incorrect order, the sentence wouldn't make much sense. So it makes sense that we would have to have an order for each of the words, or in this case, the characters in a string, as we would for the words in a sentence. So each of these, we can assign them a number. Like, for example, when you're looking at a sentence, the quick brown fox jumped over the lazy dog, for example. We can say that the would be the first word, right? And then the quick, so quick would be the second word, brown would be the third, and so on and on. In Python, it works very similarly with the characters in a string, except that we start counting from 0. So we call this indexing, and we would say in Python that indexing starts from 0. And why we call it indexing is that each of these identification numbers, or like the order of each word or character, is called an index. So that's kind of the how you identify each character in a string. So there's a specific format that we use for string slicing in Python. You use a pair of brackets, open and closed. Inside there are three parameters. That is the start parameter, and this is the first character in the string, the index of the first character in the string that you want to start from. There is the end parameter, which signifies the last character that you want to access. And it's important to note that the range that this creates from start to end, it only includes the characters from the start to the end, but not the end index. So let's say we had the word apple. Apple is made up of 5 letters, A, P, P, L, E. So let's say if we used the index 0 to 4, since indexing starts from 0. And so you can kind of say, like, I want to access the first letter and the fifth to the fifth letter. So so in this case, Apple has 5, right? You minus 1 from that, so 0th to the 4th. What this would do is it would access actually A, P, P, L, but it would not access the E. And why is that? That's because the final letter is not included. What you need to do is you need to say 0 to 5, and then it will access everything. And finally, skip. Let's say you're going from the beginning of the word, you're going character by character. So let's say you start from 0. If the skip was 1, you would only move up by 1. So you would visit each letter. You'd visit every letter. You'd start from 0, then you go to the first letter, then you go to the second letter, then the third letter, in order. Let's say skip was a different number, like 2. You would visit every second character. That would mean that you start from the 0th, then you go to not the first, but the second. And then from the second, you don't go to the third, but you go to the fourth. So you basically, the skip value is which nth character do you access each time. And the final thing to mention is that in string slicing, similarly to having indexes from the beginning, from 0 to whatever number of characters you have in your string, that you can access each character using that index. You can also access the characters from the end of the string using negative indexes. So this would start from -1. So the last character in a string would be the -1th character, which can be a little bit confusing, but we'll go through some examples. So hopefully that should sort of demystify it. So let's create some code here. Let's say we have some text. Let's use hello world, since that's a classic. Now, let's say I want to access the first word, just the first word of that. I know that hello is made up of 5 letters, and as mentioned previously, we can access the first 5 letters using the indexes 0 to 5. So let's print, and then we want to access the variable text, and we want to access the positions 0, and then we use a colon, 5. And you can put a colon here 1 to mention that you want to visit every character. Usually you just leave that empty and Python will do it automatically. So it kind of assumes that it's 1. It does the same if you leave out other colons, and we'll look at that later. So let's just see what the result of this is. So it printed the text hello, which indeed are the first 5 letters of the text. There's another way we can do this. What we can do is print, and we want to access the text variable, and we don't want to paint, we want to print. And what we want to do is we want to leave it empty, the empty colon, and then 5. And so Python will automatically assume that this is starting from 0. Same as it would if you were to set the skip to 1, we'll leave it empty, as we just saw. Let's create some more text and play around with this a little bit more. Let's say I want to access the second word. So characters can represent a large range of different symbols. That includes so-called white space characters or empty space characters, such as space. So I'm selecting it here. That would be considered a character. So let me use the same text here. And let's say now I want to access, let's create a variable to access this. Let's call it a slice, slice 1. is equal to text, so the text earlier, that's this variable that we created here, and we want to access these positions. So we know that this variable, or this character here, this is the fifth characters. So let's start from here. We go 0, 1, 2, 3, 4, 5. And since we don't want to include the space, we're going to go to the sixth character. And we want to go to the end. So we're going to count up 7, 8, 9, 10. And that seems to be the length of this string. And since we want to include the last letter, we're going to write 11. So now let's print slice 1. And we can see that it was a success. We printed the final word. And if we select this, we can see that there is no space. Let's really quickly experiment with this, and let's just try 5 to 11 first, and you'll see that the space will be included. So that just moved a little bit to the right. That means that there is a space there. Let's go back to 6, and let's try 10. Let's see what happens. So remember that the D is the 10th character here. So just to show that this is non-inclusive, that means that the final character isn't included in the range. I'm going to use the 10th index and see what happens. And as you can see, the D has not been included in the result. You can also do something like this. Let's say we have slice 2. And let's say we want to access the final word. You can also do 6, colon, like an empty colon. And just as in the previous example that we had here, it'll automatically assume that you mean that you want to go to the end of the string. And if we print that, this is what it'll look like. So as you can see, it's the same result. In case we don't know the length, or we just want to access the until the end of the string, you can use this notation, this kind of syntax. Another interesting thing to note about slicing is that you can actually access a single character of the string, and we can do it like so. Let's use the text. Let's use the text variable that we created earlier. Let's create a new variable. Let's call it character 1 because it's a single character. And we want to access the first character. We want to access the first character in the string. And we know indexing starts from 0 in Python. So we'll access the 0th character. That should be H because that's the first character. And now let's print this. So as you can see, H has been accessed. Let's try one more character just to see what happens. Let's say we want to access this O over here. So what we can do, so we know that that's the 4th character in the string starting from 0, and what we can do is we can print that. And as you can see, we have an O as an output. Let's move on to slicing with negative indices. This is something that we mentioned before, and I think the first thing I would like to look at is what a negative index kind of is. So let's define some new text, something more interesting. So lorem ipsum is a kind of filler text that you see in a lot of demos and websites, like early dev builds. We're just going to use that. Let's say we want to access the last character of that, so that'll be an M in this case. So as we mentioned earlier, negative indexing is a lot like regular indexing, except for instead of starting from the beginning of the string, you start from the end. And since 0 is already the beginning of the string, we use -1 to assign the final character. So let's just see what that looks like. And we want to use text2 at position -1, and we're going to see what that looks like. So text2 is this variable that we assigned here. And let's run this and see what happens. So we should expect to see an M as the output. And that's exactly what we got. We got an M. That's really cool. Awesome. So let's now try accessing up to a character from the end. So let's say print, and then we'll say text2, and we want to go from the -5th character. So if we go from -1, 2, 3, 4, 5. That's ipsum. That's the negative fifth character, so I, until the end. And since we're putting this at the start, and we have this notation that we used earlier, it should assume that we're going to the end of the string. So let's run this and see what that looks like. We should see the word ipsum. And that's exactly what we get. Awesome. So let's say now I want to go from the first character, so the 0th character. And since in Python we don't need to specify that, we can just add a colon there, as it assumes we're going from the first character. And we want to go up to ipsum. And let's say, actually, we don't want to include the space as well. So we know that's one more character to the left, so let's go to -6 as the index. And let's print that and see what happens. So we should get the word lorem, because that's at the beginning to the -6th, which is from the end, ipsum including the space. So let's try that. And we get lorem. Awesome. So we can see that that works. Now let's say I want to access the third character from the end to the second character from the end, but not the first character from the end, or the final character. Let's see how we can do that. So let's print, and let's access text 2. And we want to access the third character from the end, so -3. And we want to go to the second character from the end, so -2. And it's very easy for you to get confused with indexing starting from 0. Just remember, for negative numbers, indexing is normal. So it starts from 1, or -1 in this case. Always remember the negatives. So what this is saying basically is we have the start and the end. We want to start from the third character from the end to the second character from the end. And let's see what that looks like. We should get SU, since this is the third character from the end and U is the second character from the end. Okay. And it's important to note as well that as with regular indexing, the end is not included, so it's non-inclusive. So we should actually put -1 here, and we should get SU. Okay, awesome. So now let's do slicing with skip. So as we mentioned earlier, if we go up here, the notation is start and skip. And skip is kind of the, like, how many characters do you move by to create the final string. So let's create a new code statement here. Let's create a variable. So let's say we want some more text. And we're going to say the real folk blues. Okay. So so what we want to do now is, let's say we want to access every second character. So let's create a variable called every other. And what we want to do is we want to access the variable text, and we want to access the entire string. And what we can do is actually we can, as we mentioned earlier, if you just include the colon, Python will assume for the first one that you're going from the beginning, and for the second one that you're going to the end, right? So the entire string. And now we add a second colon, and this is where we add the skip. So for the skip, we want to access every second character. We'll do it like so. And I want to print this every other, and this should print every second character. So let's just look at the first few to kind of get an idea of what this should look like. So we should have a capital T, a lowercase e, then an R. So we skip over the space. We skip over the E, we get an A. So far we have T, E, R, A. And then we should have a space, because spaces are also counted. We skip over the F, then we do O, and so on until the end. And let's see what that looks like. Oh, Terra OK bus. Okay, awesome. So that's every second character. Let's say I wanted to do every third character. So let me create a new area here, and let's say every third. And we're going to say we want to access the text variable. Then we want to access the entire string, and we want to skip over every third. And now let's print that every 3 characters. And really quickly, let's just look over what that would look like once again. So essentially you skip 2, and then the third character you would print. So you would get T, skip over H, skip over E, then you have space, skip over R, E, then you have A. So T space A, skip over L and space, you have F. So T space AF. So let's see what that looks like. Alright, so we have T space AF and then KLS. Okay, so let's say now we want to access every so-called even character. So let's assume that each of these have a number that doesn't start from 0. Let's say the first character would be number 1, the second character would be number 2, as you would expect, right? And let's say we want to access the characters with only even numbers. So in this case, let's create a character called even characters, and we want it to be text. And what we want to do is we want to, just like before, we want to access every second character. But notice that Python assumes you will start from the first character. It'll start from the 0th character. What we want to do is we want to start from index position 1, which is actually the second character. So we want to start from H, because T would have the index 0, which is an even number, but in reality it'd be the first number, which is odd. So every even character would be starting from the first position and then skip over every 2. And we can do it like so. So we have the start, the end, which is assumed to be the end of the string, and then the skip, which is 2, so every 2 characters. And let's print that to see what it looks like. And we should be expecting T, E, R, A, since those are the even characters. Oh, sorry, H space E, L, since those are the even characters. And we have space H, E, L, and then some other stuff. So that works. Okay, awesome. Now, I wanted to show you something very useful. Let's say you wanted to use skipping, but you wanted to do it from the end. So a really useful application of this is, let's say you want to start from the end and you want to go to the beginning. In other words, you want to reverse the string. So how can we do that? Reversed text is equal to, and we want to access the text variable. So that's this one here, the Real Folk Blues. And we want to reverse it. So we want to access the entire string. So as we said before, when we're accessing the entire string, you just use 2 colons. And then you want to go by, you want to move by -1. And what this will do is it'll start at the end and it'll go backwards. And what you get is a reversed string. So let's see what that looks like. So we should expect SEULB first, and then the rest of the text backwards. And that looks like SEULB and then the rest of the text backwards, including the spaces, which is really cool. So let's try one more thing. Let's create a palindrome, which is a word that's the same backwards as it is forwards. So for example, race car. So race car is the same forwards as it is backwards. You can pause the video and test that theory if you don't believe me. So what we want to do is we want to print palindrome. And we want to use the same method as we used before, so access the entire string, and then move by -1 each time. So let's run that and see what happens. And we get race car. So we have proved just now with code that race car is the same forwards as it is backwards. Very awesome. Okay. So now we'll be looking at string functions. In Python, there are a number of built-in functions that allow you to play with the strings, to access different parts of them, to manipulate them, or to interpret them, to see properties of them. So it allows you to see some properties of them as well. Let's look at this first function here. This is the len function. And len is short for length, basically. So let's say I have a word hello. So let's define a variable word hello. And what I want to do is I want to get the length of this word. We know that this word is 5 letters long, 5 characters long as well. So let's get length, and we'll set that to, and we'll use the length function, so len, and inside we want to put our variable word. So this function is going to take our variable word and it's going to give us an integer, or a number, basically, which is the length of this word. So let's test that real quick. So we know that hello is a 5-letter word. Let's see what we get as soon as we print it first, maybe. So let's print this and see what we get. And we get 5. Awesome. So that proves our theory that hello is a 5-letter word. Let's try now seeing what happens if we have an empty string. So empty string is equal to, and then we put nothing inside the quotation marks. Or maybe let's use these quotation marks. Why not? We haven't used them very much. And then we'll get length is equal to the length of empty string. We'll print length, and let's see what we get. And 0, we get 0 because it has a length of 0. There are 0 characters in this string, which is correct. There is nothing in there. I also wanted to demonstrate what happens when you have spaces inside of a string, so they're also counted towards the length. Let me create a string here. String with spaces. And I'm gonna define the quick brown fox. And now what I want to do is length is equal to the length function of the variable string with spaces. And now let's print that variable, or let's print the length, and let's see what we get. 19. Okay, now this doesn't really prove anything. What I'm going to do is I'm going to remove the spaces here. So we had the result of that being 19. That was the length of the string. If we run this code again and the length changes, that means that the spaces were actually included in the length. If it stays the same, that means that it did not count the spaces. So let's test our hypothesis. And we get a number 16, which is 3 fewer than 19, which means that it did indeed count the spaces in the length function. This function is called ends with, and it returns a boolean, which is a true or false variable. This can have two values, essentially. So what this function does is it tells you if the string you have ends with another given string, so another string that you give it. So let's create a string just to test this out. Let's create a variable. Let's say text is equal to, we'll have 33 spelled out. Now let's say we have another variable, a is equal to 3. We'll have b is equal to the number 3, and then we'll have c, which is equal to 2, spelled out as a. Now let's get a result variable, and inside this variable we're going to store the boolean that we get from the ends with function. So let's access the text variable that we created earlier. This has all the text that we have, so 33 spelled out, and then we're going to use the ends with function. Inside that we're going to test for a. So what we're doing here is we're creating this variable result, and we're saying this variable is equal to the result of the function ends with testing for a, so 3, applied to the variable text, which is 33. So what we're saying is this variable result is equal to if text 3 ends with a, which is 3 spelled out. So we know that it ends with 3. So we should expect a true result. Let's test that. And we need to print that. So print result. And we have true. Let's test for these other variables here. So result is equal to text dot ends with b. And let's just print that. Print result. And let's see what we get. We should get false, since we know that this is 3 spelled out and this is 3 the number. So we should get different results here. False. And now let's once again access result. Let's say it's equal to text.ends with and then c, so we're testing for the c variable. And let's print that result. We should also get false, since we're testing for 2 and this ends with 3. And that's exactly what we get. There's another thing I wanted to test out. Let's print the result of testing the variable text. Let's see if it ends with 3 spelled out with a capital T. And that's false. And you might be surprised, but because we used a capital T, it is technically a different character. So these functions, we could say, are case sensitive. That is, the case of the letter, so whether it's lowercase or uppercase, capitalized or not, actually affects the result of using these functions. And it's the case with a lot of the functions, so keep that in mind. There is also a starts with function, which works very similarly, but from the start of the text. And we can just really quickly test that out as well. So let's print the result of testing text, the variable text, and then we're going to see if it starts with 30. We should get true. And that's what we get. So you can extrapolate, you can guess what would happen if I applied this with a bunch of other cases, but I think I'm going to move on to the next function. So we're going to look at the count function now. And what the count function does is that it looks through the string and you give it another string, and it'll tell you how many times that string shows up in the first one. So let's say we have a text, and let's say the quick brown fox jumps over the lazy dog. And we want to have a new variable result. Let's call it result, or we can even call it variable 1. And we're going to say, and let's say that it's equal to the result of testing the variable text with the count function. And let's count how many spaces are in this string. And now let's print the result of that. And we should get, let's count quickly, 1, 2, 3, 4, 5, 6, 7, 8. So we should get 8 as a result. And that's exactly what we get. Awesome. Now, it is said that in the English language, E is the most commonly used letter. So let's test that hypothesis. Let's use the text variable. And we want to print the result of testing the text variable with the function count. And let's count the number of occurrences of the character E. So let's test that really quickly. And we don't want to pint, we want to print 3. Okay. So there are 1, 2, 3. Let's finally test one more thing, and let's print the result of text. We want to access text variable, and we want to count the number of occurrences of the word fox. And we know that fox only appears once in this entire sentence, right? And so we get the value 1, correct. Another thing I want to test is the result of testing the variable text and seeing how many occurrences of the word the are inside of this string. And we get 1. Now notice that because the first letter here is lowercase, it does not count the first letter here, with a capital. So just once again to show you, these functions are very case sensitive. So keep that in mind because it's sometimes easy to forget when you're programming. Okay, we're now going to be looking at the capitalized function. And you might think that what this does is it turns every character in the string from lowercase to uppercase. But what it actually does is it makes the first character uppercase. And if it's already uppercase, then it stays the same. So let's say we have a string, text, is equal to proper names should be capitalized. And we're going to have another variable here, and we have lowercase. So let's just concatenate those real quick, see what we get. And we get proper name should be capitalized Amir with a lowercase. Now let's fix that. Let's take this name variable and let's add dot capitalize. So we want to apply, when we're using this dot, we want to apply the capitalized function to this name. And it is a function because it returns this string with an uppercase first character. So let's see what that looks like. Let's run this. And we can see now that the first letter of Amir has been capitalized. So the function works as expected. Let's try one more. So let's use the quick brown fox jumps over the lazy dog. And we want this sentence to be capitalized. So let's turn it into a proper sentence by creating a variable called proper sentence. And we're going to say that this sentence, this proper sentence variable, is equal to sentence with the function capitalized applied to it. So we're going to capitalize the first letter. And now what we want to do is we want to see the result of that. So let's print proper sentence. And let's run this code to see what happens. So we can see it's been transformed. The first letter is now a capital T. So very cool. The function works. So now let's look at the find function. This function is a very interesting function. What it tells you is the index of the character in the string that you're looking for. As we discussed earlier, each character has its own unique index in a specific order in the string. Let's note some of the interesting properties of this function. One of them is that, as with other functions applied to strings, it is case sensitive. So if you have a lowercase e that you're looking for in the sentence, it's going to skip right over all of the capital E's. Another interesting property is that if you have multiple characters that you're looking for, it'll return the first one in the string that it finds. So let's say you have a lot of E's. As we know, E is the most common letter in the English language. If we applied this function to, let's say, a long piece of text, we might be disappointed to find that since it can only return one integer, one number, one index, and let's say the sentence starts with the word the, it would return 2. It would return the first E that appears in that sentence. So The final property I wanted to talk about is that if the thing that you're looking for, which can be either a character or it can even be a string, so a word, for example, or some other combination of characters, if that is not found in the string, it'll return a -1. So that's how you can test for that. Let's test this out. Let's create a text variable. Let's use some Latin here. And what we want to do is we want to have let's find the location of e in this string. So e location is equal to old lie dot, so we're applying a function find with the parameter e. I'm going to put that inside quotation marks. So it's going to look for e inside of this string. And what we want to do is we want to print the result of that. E location. So we want to print the e location variable. And we run this, we get 4. And to test if this worked correctly, let's start from the first character. And as we know, indexing starts from 0. So D would be 0, U would be 1, L would be 2, C would be 3, and E would be 4. And let's check over here. We have 4. Okay, awesome. So we know that it works. And as you can see, there are multiple E's in this text. There's one here. There's one here. There's even one here, actually, that I missed. And it returned the first one. So it gave us 4. Let's say we're going to look for a word now. So as we know, this E here appears at the position 4. If we go one more character to the right, we get 5, and 6 is the position of the next E. Let's maybe test, instead of for this E, let's test for et, which is the second word in the sentence. Since it begins with this letter here, this character, which is at the 6th position, we should expect that we get a 6 as the result. So let's find et location is equal to, and then we have the variable old lie dot find, and we want et. And let's print that. And as we said before, we should expect a value of 6. And we get 6. Awesome. So we know that that works. Let's look for something that isn't in here. And something I definitely don't see in here is a random goggle of different special characters. So let's just try that out, just some random special characters, and see what happens. So let's create random characters. Not truly random. We are making these up. We could also just use something that doesn't appear in the text, like ASDF, for example. Let's test it for that, actually. So let's print the result of testing the variable old lie, which has our text inside of it, with the function find. So we want to find something inside of that text, and what we want to find is random characters, the variable random characters, which is ASDF. So if ASDF appears at any point inside of this text, we should see a index of it ranging between 0 and infinity. Note that in real life, you would not find a string with an infinite length due to the limitations of physical hardware, so that wouldn't be possible. But let's see what we get. And we get a -1. And as we discussed earlier, what this indicates is that it was not found in the string. So I think this actually covers all of the cases that we've covered previously. Let's move on to the next function. So let's look at the replace function. What the replace function does is that it takes one character or one string and it replaces it with another character or string in a given string or a given variable. So let's create a variable here. Let's call it text. And let's just write something, some filler, the quick brown fox. Awesome, with a full stop at the end, why not? And let's say I'm really angry about this the not being capitalized, but I'm a bit more angry that it's not fully capitalized. So let's say I want to create a new variable, and let's call it better text, and is equal to text. And let's say we want to replace this the that we have with a fully capitalized the. So we're very angry here. And now let's print this and see what we get. So let's print better text, which is the new version, with replacing the with fully capitalized the, and let's see what we get. And we get the quick brown fox. Okay, awesome. Now, let's say I don't like this color, and I want to change it from brown to something more interesting looking. Let's say we have a bright orange fox. So orange text is equal to text dot replace. So we're applying the function replace, and we want to replace the first parameter, which is going to be brown. So with the first word, we want to replace the second parameter would be the word that we want to replace it with. So we want to replace brown with bright orange, maybe neon orange. And now let's print the result of that. So print orange text. And we get the quick bright orange fox, which is exactly what we're looking for. So that's pretty cool. Another thing you can do is you can actually replace things with an empty string. So let's say I don't like these spaces. I want to get rid of all of these spaces. What I can do is I can say text without spaces is equal to text.replace, and we want to have spaces, so we have a space character in there, and we want to replace it with an empty character. Let's print that and see what we get. And we get the quick brown fox without any spaces. Let's take a look at escape sequence characters. Escape sequence characters are a kind of special character, and in programming what we use these for is certain situations where we want to represent a property of a string, and let's say we want to designate characters to letters and numbers and all that. But when we want to represent one of these characters, what we do is we use a backslash. So they actually take up two characters. They use a backslash and then another character. So backslash followed by another character, but they represent one character. So the first one of these would be a new line. And what this is essentially, let's say you have a sentence or a paragraph, and when you read text, when it reaches the end of the screen, usually it goes back to the left. That would be a new line. So a new line is created. A tab is a large space separating two parts of a string, and let's say now you want to use this backslash in the text, but it's reserved for escape sequence characters. So what we can use is a double backslash, and that'll just include the backslash in the text. Let's try this out. So let's create a string. Let's call it string1. And let's say it's hello world. And then we want to say this is a new line. So notice I put /n here, and my environment, Visual Studio, is showing it in red, and this is to show that it's an escape sequence character, it's a special character, so it's being treated differently. So what will happen is that when this text is printed, what you'll see is actually that these two pieces of text separated by this escape sequence character here, by this new line, will be on two different lines. And let's test that out. Let's test out that hypothesis. Oh, so we can see hello world, the first part, is on its own line, and then this is a new line, is on its own line. Now, I want to try something really cool. I want to show you a cool application of this. Let's say we have a lot of text here. Let's say we have string2 is equal to hello world, how are you today? And let's say I want to print every one of these in a new line. So what I can do, let's create a variable called separated, and we want to access string2, and we want to replace space with this escape sequence character. So /n. And now let's print this variable, and what we get is hello world, how are you today? And you can see these are all on their own lines. So I replaced these spaces with /n's, and just to show you what that would look like, let me replace these manually, and we should get the same result. And let's just print string2, and let's see what we get, and we get the same thing. So that's just one way of doing it. Put this back to how it was. Awesome. So let's look at tab. What does tab do? Let's say we have words, two words, and we're gonna say hi mate. And let's say I don't like this space, it's too short, let's add a tab, so /t. And now let's print this. And what we get is a bigger space, hi mate. You can see is much larger than a space. And this is usually used for separating different content inside of a string. Let's say we want to do something similar to what we did before. So let's take this string2 here, let's copy it over here. Let's call it string3. And let's say what we want to do is we want to have a new variable called widely separated, and we want it to access string3, and we want to use the replace function, and we want to replace the spaces with the escape sequence character for a tab. So that should basically widely separate our text. And let's print this, of course. And let's see what that looks like. And you can see now each of these words has a very big space in between them. Okay, let's look at backslash. So if I try to just create a piece of text here with backslashes, this text has a backslash. Instead of an L, I'll use a backslash. And what you'll see is that Python automatically thinks this is another kind of escape sequence character. And if I try to print this, let's see what we get. Oh, you can see there's a special character here, and we don't want that. We just want to have this with a slash. So what we can do is a double slash here, and it'll just replace that with what we wanted, which is a slash. So a slash instead of an L, in case you wanted to write in a quirky style. Let's move on to raw strings. Another way that you can deal with these backslashes and escape sequence characters being interpreted differently by your IDE or your environment is you can use raw strings. So let's create a string here. Let's violate all of the rules. So the way you do this is you place an R before the quotation marks, and let's say now I want to create a string, this text, and then let's say we have a slash n. So this would create an escape sequence character for a new line, has slash t. This would create a tab, so a very big space. Escape sequence characters, and now let's have a double slash. So there should be one slash only if we're using escape sequence characters. And let's print this. And what we should get, what we should be expecting is that to be a line break here. So these lines should be separated. We should be expecting a large space between has and escape, and we should be expecting one single backslash here at the end. And what we get, we get the exact same thing that we wrote in between the quotation marks. And that's because raw basically tells Python, okay, it doesn't matter what backslashes we have. It doesn't matter what you think the escape sequence characters we have. Pretend they don't exist and just write exactly what I wrote in between these quotation marks. So this is useful if you want to use these characters in your text and you don't want Python to interpret them differently. This is how you would deal with that. We'll talk about some applications of this later in this course. Let's take a look at the final part of this episode, which is string interpolation. And that's a very fancy way of saying, okay, strings are awesome, and I get that I can concatenate different things together, but it kind of takes a long time, and I want to do it in a more intuitive way. So it takes a look at that problem, and it says, oh, I've got a great solution for you. And what this is let's say you have some variable that isn't a string, and Python has a way of converting these into strings, which you might have seen in previous episodes, and it uses a lot of syntax and it's very bulky. So what you can use is string interpolation, and Python will automatically convert those strings for you, and everything will be positioned in a very intuitive way. So one of the ways of doing this is with f strings, and I think the best way to explain this to you is just kind of by showing it to you. So let's say we wanted to follow in a previous example. Let's have a prompt. And let's say my name is, and let's say I wanted to put my name afterwards. What we would do is we would have a plus here, and we would have a variable called name, and we would add that. But let's say I want to do it differently. Let's say I want to have it inside. What I have to do is I first have to define a name variable. So let's say the name is, well, my name is Eric, so let's put that in here. And I want to say my name is, and what you have to do is at the beginning of one of these strings, as with the raw strings, you put an F, so it's an F string, you put it at the beginning, and what you can do now is you can use braces, which are these squiggly kind of brackets or parentheses, if you want to call them that, and then you put the name of the variable you want to put in that. Python will automatically convert that for you if it can be converted into a string. And let's print this to see what it looks like. So it's print prompt, and it should say my name is Eric, and let's see what it says. And it worked. So this is a really cool way of doing that. Let's look at some more examples. Let's say we have some operation that we want to track, right? So let's have a variable 1, or maybe let's for simplicity call it a, and we'll have 12, and then we'll have another one called b, and we'll have it b equal to 6, and we'll have c equal to 18. So we kind of have done this operation before. Let's see what it looks like. We'll have a variable d is equal to, and we want to create an f string. here, and we're going to say the variable a inside these braces, and we want to have the character plus. So everything that's in the braces will be treated as a variable, and everything outside of the braces will be treated as a character, including these spaces, including these characters like plus. We'll have another variable b, and then we'll have the character equals braces, and then c, the variable c. And now we should have a cool string which has all of these variables inside it, and is a much simpler way of kind of having variables inside of your text. So let's print d just to see what that looks like. And we have 12 plus 6 equals 18. So that's a really cool application of this. Okay, so that is the end of this episode. I hope you guys enjoyed this.
Hello and welcome to aorbtech. Today we're going to discuss continuous series of the Python Learn to Py, and this is a fifth episode about Python. In this episode we will briefly discuss about list and tuple. This is most important topic in this Python. So what is list? A list is basically simpler container which store a value, and this value could be any data type. Any data type mean it could be integers, it could be string, it could be a boolean value. So let's say I wanted to create a list A, and I am going to create integers value. Let's say that integers, and if I run, and it will return the results. So basically in this list that I create is based on the integers value, so it's just number. So if I check the type, it will return as a list because we create a list. So by using square bracket we can create a list. I mention any data type here, so let's take another example where we can store different data types. Let's say that I create another data type. So let's say that we create another list here, and in this list we take string value, we also take integers value as well. So it could be any data type value. So if I check the type, and it will say it's a list. So in that way we can create a list. Next one is list indexing. List indexing is basically showing the index number of the element which present in the list, and it's always start from the 0. So let's take an example. We already create a list B. So if I run, this is a list that we create. If I wanted to check the element of index, so let's say I wanted to take 0 index, and in the 0 index as we can see it's 1. So if I take another example, and if I say that 3, and if I run it, and it will return at A. So basically 0, 1, 2, 3. In 3 index we have a string value which is A. So let's take another example. Let's say that 9. So 9 is basically, we don't have index values. Why? 1, 2, 3, 4, 5, 6, 7, 8, 9. But index start from the 0. So the last value is basically in the indexed 8. And here we take the index 9. So we don't have, that's why we get the error. So if I take B8, it will return the last element which is 6. So this is how list indexing is work. Always keep remember that the list indexing is start from the 0 until the end of the element. So as you can see here, because our element are 9, but when we get the excess of the 9 indexed, we don't have index. So because it start from the 0 to uh, n. So here our n value is 8. So when we give the index value 8, it will return the 6. So this is how the index is work in the list. The next one is list slicing. List slicing, maybe you familiar with the slicing word because we already discussed very briefly in our previous video string, and in the string we did slicing. We discussed very briefly this topic. Here we will discuss how the slicing is work in the list. The same approach. So if we see the pseudocode here, the list is basically start the index value. Remember this index value is always start from the 0, and the end value whatever the value we define, so it's basically take the value from the start to end. And the step is basically how many element we want to skip. We will see about the step example in the end of this list slicing topic. So let me create another list to explain how the slicing is work here. Let me say that I wanted to create a list 1 to n. So here we take the element 10, very simple integers value, and if I wanted to slice, so let me take the example. If I say that this sign, it will take all the element, which means it's taking all the elements started from the 0 until the end of the element. But if I wanted to define the range, let's say that 0 to 5, so if I return, it will return from 0 to 5 index values. As you can see here, from 0 to 5 index value until 5. Let me show you how it's work. So let's say that 0, 1, 2, 3, 4 and 5. So it will return from 0 to 5. Remember 5 is excluded here. So how it will work, like from 1 to 5 it will return the values that we define here, the range. Let me show you another example. Let's say that I wanted to take a range from 1 to, for example, 2. So if I in the bracket, so how many values it will return? Let's see. So 2. Why 2? Because as we know that 2 is our excluded, and the index value it will start from the 1. So which element at 1 index? As we already know that at 1 index we have 2, so that's how 2 is written. So let me give another example. Let's say that I wanted to take the value from 5 index to on. So it will return all the remaining element of the list. Why? Because we start index 5. So let's say another example, 0, 1, 2, 3, 4, 5. So we start from 5 until the end of the element 10. So we define 10 and it will return the index value of 10. So this is how the slicing is work. I already mentioned step. Let me show you example how the step is work. So let's say that I wanted to take a num, again slicing, I'm doing slicing. So let's say that, so if you can see here, we take all the element from the list, start from the 0 index to 10th index, and it will show 1 3 5 7 9. Why? Because it will skip every second element of the list. So this is how the step function is work. Let me show you another example. Let's say that I'm going to take the element, but if I say that 3, if we'll see the results, it will skip every third element. So 1 will be show, then 2 3 will be skip, and then 4th will show, and then 5 6 will be skip, and then so on. So this is how the slicing is work. I wanted to show another example of negative index. Let's say that I wanted to take the element and I wanted to take only -4. So if I just me remind you, so if I wanted to remind you that, as we know that it is basically this is our the list, and -4 is basically the opposite. So this is -1, -2, -3, -4, -5, -6, -7. So this is how it works. So if I return here -4, which is 7, and that's how it's return the value of 7. Let me show you another example. Let's say that I wanted to extract the value from 7 to onward. So let's say that -4 if I return. So this is how we take the value. Why? Because we take the index value -4. So basically in this example our index value is start from the 7 to onward. So we defined no and so it's basically take all the values here. So if I take this one and if I skip 2, it will return only 2 values because it will start from the 7 until the end of this number, and by skipping every second value. So 7 will return, then 8 will skip, then 9 will return, and then 10th will be skip. So this is how the slicing is work. I hope you will understand. Feel free to write the comments. I will be help you if anything is unclear here. The next one, change item in the list. In this topic we will see how we can change the element in the list. So let's say that I wanted to take a list, and this list is basically mixture of data type. So it is integers, we have a string, we have a boolean, we have float, then we have a none. So let's run first the list, and this is the list that we create here. And let's say that I wanted to change our boolean value. So let's say that how I can change it. So let me show you. Let's say that I wanted to okay, so let me explain how it's work. So I take the index value 2, which is already known that 0 1 2. At 2 index we have a false, and then we change false with the true, and we just simply run, and as you can see the result is basically false is replaced with the true. Let me show you another example. In this example, let's say that I wanted to change Amir with Ali. So let's say that mix list. So I take the index value 2, in index value I take the index value 1, as we know that in 1 we have Amir, 0 and 1, and I replace with Amir with Ali, and if I run, as you already know that this Amir is replaced with the Ali. So this is how we can change the item in the list. Next one is basically list method. List method is pretty much useful because we perform a different operation using this list method, and let me show you one by one with example. So let's say that we have a list here with the different unordered integers, and the first method is basically sort. How the sort is work? So let's say that I have let me show you with the example. Let's say that list let's say that 3 1 5 3 again 6 8 2 3 4 1 1. So this is a list that we take, and let me show one by one example. So the sort basically how it's work. Let's say that we have a list 1 8 7 2 21 15. The sort is basically sort the element from ascending to descending order. So how it will return 1 2 7 8 15 21. Let me show you how it's work with the example that we take a. So let's say the a dot sort. If I run, so as you can see, this was the list, which is basically unordered element from the list is here. And if I use the sort function, it's basically sort from ascending to descending. So we have 1 3 3 5 6 7 8 9 11 22 34. This is how the sort is work. The next one is basically reverse. Let me show you with the example. So let's take the same example, and as you can see, this is already sort. So if we reverse this list, how we can do that? So let's say that reverse. So if I run, so it is basically reverse the element. Yes. So as you can see, it's a reverse the element. So we can see this was a list, and using the reverse method we reverse the element inside the list. The next one is basically append. Append is basically nothing but just the value it will concatenate in the end of the list element. So let's say that I wanted to append 33 in the end. So basically let's say that this is my list and I want to append the value a dot append. Let's say I wanted to add 100. So as you see here, so if I append 100, it was basically append. Let me show you another example. So let's say I wanted to append 200. So let me run. So as you can see, we append. If I run this code again, see how this is basically append. So if I run again, it will append another 200, and then if I run again, it will append another 100. So this is how this is work. The next one is basically insert. So let's say that I have a list of num, and we already create a list before from 1 to 10, and I wanted to insert 3. Let's say that I wanted to insert at one index 5 value. So how I can do that? So num dot insert. So let's say that I wanted to insert a 5 value at index 1. So if I run the num list, and as you can see, we insert 5 element at index 1. Let me show you another example. Let's say that I want to insert at 0 indexed some string value. So if I run, as you can see that 1 is appear here because we insert at 0 index a string value a. So this is how the list insert is work. The next one is pop. The pop is basically a delete the element, and there's a two things here. Keep in mind, pop is basically when you wanted to delete the element, we basically define the index. Let's say that I have a list of num, and I wanted to delete the index value which is 5. So how I can do that? As you know that at 5 we give index 1. So num dot pop, and if I say that I wanted to remove 5 values, so I need to define the index of 5 here. So if I run num, and it will remove. So basically in a pop you basically define the indexed here, and it will basically delete the value. So let's say that I wanted to remove uh, from this list 1 here, so you need to define and the indexed 0, and it will delete. So this is how it's worked. Let me show you how it's worked. Let's say that I wanted to 0, and if I run, it will basically remove this element which is written here. And if I show you the list, as you can see that one element is popped from the 0 indexed, and the remaining list is start from the 2, 3 and so on. So this is how pop is work. Let me show you with the example how remove is work. Let's say that I have a mixed data type of list, and let's say I wanted to remove the value of Amir. So how I can do that? I just simply add the mixed list dot remove, and then you have to mention the name that you wanted to remove. Mention the name, which means you need to directly mention the value. So if I return my mixed list, as you can see that Amir is removed. So let's say that you wanted to remove the integers value here. So let's say that you wanted to in, integer or float. Let's say that we wanted to remove the float value, and the remaining list is basically 3, false, none. So we remove basically the float value. So this is how the list method is work. Let me recap quickly. So we discuss various list method. The first one we discuss sort. In a sort, basically it's sort our value from ascending to descending. So we see that our list is basically unordered here, so using the sort function we basically sort our values. The next one is reverse. It's basically reverse the order of the elements. So let's say that we have 1 2 3. If I use reverse, it will say that 3 2 1. So basically it reverse. Then the next one is basically append. In the append, basically you can append the value, any value, just directly give the value, and it will basically append in the end of the element of the list. So let's say that we have a list 1 2, and you wanted to append 5, so just simply append 5, it will say that 135. So this is basically append the value in the end. The next one is insert. Insert is basically you basically insert the value by defining the index. So let's say that we wanted to at 3 you wanted to replace insert at 8. It will not replace, it will insert basically. So here we see that at one index we insert the value 5. So this is how the insert is work. The next one is pop and remove. Basically both is basically delete the elements from the list. Pop is basically you have to define the indexed to remove the element, and in the remove you simply have to give the value that you wanted to remove. So this is how the list is work. So let me recap quickly. In the list we see what is list, and then after that we we create a multiple list here. Then by creating the list you just define a square bracket, and then you also check the type, as we see that is a list. And then list indexing is basically, as you know that list indexing start from the 0, keep in mind. And then we see the list slicing. We see couple of we did take multiple example here. So it's basically start and then step function is basically and which element you wanted to skip. So after that we'll see how we can change the item in the list. We simply gave the indexed value and then we can define which element you wanted to change. So as you can see here, there's Ali is replaced with the Amir and then so on, and then in the end we see the default list method. The next topic that we discussed today is tuple. Tuple is also a container which store any data type values, but there's one thing, it's a fixed. Fixed mean is we cannot change the element once we create a tuple. And so let me show you how we can create a tuple. Let's say that I wanted to create a tuple. So for the tuple we use curly brackets. Let's say that I wanted to create a list integers value here, and if I run here and it will return our tuple. So if I check the type of tuple, sorry, the A, and it will show us the tuple, because we whatever we write inside the curly bracket, it will consider as a tuple. So this is how the tuple is work, and this is how we can create a tuple. So there's one thing I wanted to mention here. So let's say that I wanted to create a B tuple, and let's say that I take only one element, and if I return it will show 1. But if I check the type of B, it will say integers. Why not tuple? To create a scalar value in the tuple, we have to write comma, and if I run again and if I check the type, it will show the tuple. So to make sure, because sometime interviewer asks you if I create a scalar value inside the curly bracket, what is the type? So you have to make sure that if we create a tuple scalar value, we have to make sure we also mention the comma as well, so it will define the data types, which is a tuple. We can create multiple data types values inside tuple. So let's say that I have a num in the tuple. So let's say that 1 2, and I wanted to create a. So if I num in, if I run, so it's basically showing you the mixed mean integers and string value. So if I check the type of num, and it will show as a tuple. So this is how we can create a tuple. As I mentioned, that tuple is the same thing as a list, but there's a one small change, that it's a fixed. We'll see further how it's fixed. So the rest of properties is the same. We can create a tuple using small brackets, and we can store any data type values, so like integers, float, string, boolean, and so on. So this is how we can create a tuple. Let me show you how the tuple is unchangeable. So let me create a, and let's say that I wanted to take from 1 to 10 value, and if I run, and it's basically we create a tuple with the value start from 1 to ending 10. So let's say that is unchangeable. How is unchangeable? Let me show you. So we say that we take index value 1, as we already discussed very briefly how the indexing and slicing work. This is just I wanted to show you why it's unchangeable. So let me show you. So I wanted to replace at one index, which is 2 and 3. So if I run a, as you can see that tuple object does not support item assignment, which means that we cannot change the element. It's a fixed. Once we create a tuple, after that we cannot modify the tuple. So this is basically take differences from the list that we discussed before, because in the list we can modify, we can change and the list based on our the requirement, but tuple is basically fixed, and once we create tuples we cannot modify or change it. So already discuss slicing and index in the list before, and this is same way working here as well. So indexing always start from the 0 to onward, and same slicing concept is work. So let me show you quickly one example of slicing and indexing in tuple. So how the slicing is work. So let's say that I wanted to take the element from 1 to 5 only. So 1, as we can say, start from the 1 indexed and ending from the, say, if I show you the exactly our tuple, so 1 we have a 2 3 4 5 until 2 3 4 5 6 is excluded. This is how it's a return, and the indexing is the same. It started from the 0 1 2 3 4 5. So same, we already discussed very briefly in a previous video how the slicing concept is work in the string, and also see a couple of example in the list video as well. So just wanted to show you the slicing concept is working same. Doesn't matter it's a list, it's a string, it's a dictionary, we will discuss further video, and either is tuples. The next topic is basically tuple method, and we have a two method. One is count and the one is index. Let me explain one by one with the example. Let's say that we use a count. Count is basically count the value from the tuple. So for example, let me show you with example. Let's say that I create a tuple and I say that 1 2 2 3 4 5 2 1. So this was the tuple that we create here, and if I wanted to count the value, let's say that I wanted to count 2. So let's say that I wanted to count 2 and it will run 3. Why? Because as we know that count 2 is basically repeat 3 times, 1 2 and 3. Let me show you another example. Let's say I wanted to count 1. And it will return 2. Why? Because 1 is basically count 2 time. 1 is in the start of the tuple at index 0, and the last one is basically at 1. So this is how the count is work. The next one is basically indexed. Index is basically check the index of a given item. So let me show you with the example. Let's say I wanted to check the index of 2 and it show me that 2 is present at 1. So it basically show us the index of a given value. So as we can see that 2 is present at 1 index. Why it's not showing 2 or like 3 or may the second last tuples value? Because it's always show you the first value. So as you can see that he start from 0 index to onward, and as soon as he see the 2 value, it will return the index 1. So let's say I wanted to check the index of 0. sorry, I wanted to check the index of 1. Let's say that 1, as we can see, that appear in the start of the tuple indexed at 0, and also the nth last element of the tuple, but it will show me the 0 index because it always start from the 0. As soon as he take the element is match, it will return the values. So this was the method of tuples. We discussed two methods. One is count. Count is basically count the element from the tuple. We see couple of example here, like if I wanted to count 2, it will return like 3 time count. And same in index, basically in index we basically check the index of a given item. So if we provide the value using index function, it will return the value of 2 indexed. That, as we can see here, it's fun. So this is how the tuple is work. Let me quickly recap the video. So in this today video session, we discuss very briefly list and tuple. List, as we can say that list is basically we can store any data type values. It can be integers, strings, boolean, float, same as tuple. The basic differences between list and tuple is that basically tuple is working same as a list, but there's one small changes because the thing is that the tuple is unmodified, or we cannot change the tuple. Once we create a tuple, this is basically fixed, and after that we cannot change modify it. But in list we can do that. We also see list slicing, list indexing. Then we also check a couple of method in list, for example sort. We also check reverse, append, and so on. And same in tuple, we see how we can create a tuple using small bracket. Then we see how the tuple is unchangeable. We also try to change the element, but it giving us the error. And then we also see a few example of slicing, indexing, and then in the last we discuss two method of the tuple, which is count and the indexed.
Hello everybody and welcome to aorbtech. Today we'll be doing another installment in the Learn to Pi series, and we'll be looking over dictionaries and sets. So in this episode we'll be looking at creating dictionaries, accessing dictionaries, dictionary methods, creating sets, and set methods. So let's get started. So what actually is a dictionary? Well, a dictionary in programming is a data structure that stores key value pairs. And what that means, that's basically some jargon in programming. What that means is that you have an input, and for that given input, that unique given input, you will always get an output, a value. So you have that input, which is the key, and then you have a value which you get from that input. So let's look at some properties of dictionaries. Dictionaries are unordered. Dictionaries are mutable, and dictionaries are key unique. Let's look at the mutability. I think that's the most simple one to understand. Mutability basically means that a variable can be changed during the runtime of the program. Basically, you can update dictionaries while the program is running. You can change their size, you can add to them, you can remove from them, and you can update them. So unordered and key uniqueness. What does this mean? Well, let's look at key uniqueness. Basically, a dictionary, every single key has to be unique. You cannot have two of the same key. For example, let's say that in our dictionary we use integers as keys. We can't have one as a key and then another one as a key. There can only be one key, if that makes sense. Or maybe if we use the example of a giraffe as a key, you can only have one giraffe in the dictionary. And this is why dictionaries are often unordered. Basically, it's difficult to order something when you don't know what data type or what variable it's going to be as the key, because it can be anything. It can be a string, it can be an integer, heck, it could be an animal, right? So that's basically the properties of a dictionary demystified for you. So let's look at how you can create a dictionary in Python. Let's create a block of code here. And let's say dictionary. 1 is equal to, we want to use braces here. This is what defines a dictionary, is braces. We press enter and Python or your IDE will automatically place these braces like so. And now we can create our key value pairs. And you do this by separating them using a colon. So on the left we'll have our key and on the right we'll have our value. Let's use the example of an actual dictionary so we can kind of grasp how this works. So as I said, you can have any data type on the left and any data type on the right. So let's use strings because they're pretty easy to manipulate and they're pretty abstract. So let's say giraffe. Yeah, there we go. And we want to have a definition now for what a giraffe is. And it's just a horse with a long neck. And there we go. We've created our first dictionary. And it only has one entry. It only has one key value pair, but it works. If you want to add more, you simply have to add a comma here and then input your next entry. So let's say now we have a shark. And a shark is just a fish with sharp teeth, right? That's just what a shark is. Let's say we want to have one more. Monkey. And a monkey is just an unevolved human. Having some difficulties there spelling human. And there we go. Now we have a dictionary. So we have 3 entries here. On the left, we have our keys. On the right, we have our values. Let's just do one more example for clarity. So let's add another code block. Let's say grades. That'll be the name of this dictionary. And then we'll use the braces again. Now we want to enter a key. So let's say Eric. And Eric has a grade, or let's say a GPA average of 3.73, which is not bad. As you can see on the left, we have a string as the key. And on the right, as the value, we have an integer. And you can change these for each dictionary. So depending on a dictionary, if you want to have something different, you can. Let's say now I want to have Amir, and he has a grade average of 4.0. Wow. Got an ambitious guy over here. And now let's say I want to have something else, something slightly different. Let's say I want to have Eric country code. Now we have this. We have our key on the left, we can have a value on the right. And now we can enter another string. So I'm going to input plus 48 because that is the country code for Poland, which is where we are right now. So as you can see, it doesn't strictly have to be the same key value pairs. You can have a string on the left and an integer on the right, and then you can have a string on the left and a string on the right. So that's pretty cool. So you might be thinking, cool, I've created a dictionary, so what? How do I access the values on the side? All you have to do is create another code block, then print. And now let's access one of these dictionaries. So let's say dictionary 1. First we need to run these. And now, remember how when we were talking about a dictionary, we said that the key value pairs are basically just an input and then a value for that given input. So all we need to do is access that value by using the dictionary it is stored inside. So let's say dictionary 1, and then using brackets, like as if you're indexing something. And now we want to input the key, which is giraffe. And what we should get from this is the definition of a giraffe, which is a horse with a long neck. Let's do another example. Let's say I want to access something from the grades dictionary. What I need to do is print. Then I want to use the dictionary grades. And I want to access the value associated with the key Eric. So all we need to do is print that. And there we go. We should get the grade for Eric, which is 3.73, as you can see. Now let's say I want to access these on the left. So you can't actually do that using the values. If I try and do that, let's print. Now let's access the dictionary grades. And let's say I use, in the brackets, the value plus 48. And let's just print that and see what happens. You'll see I get an error. That's because plus 48 isn't a key. And basically, a dictionary is one directional. You can use a key to get a value, but you cannot use a value to get a key. And this is why all keys are unique, because you have one key that defines any value, even if that value repeats multiple times in the dictionary. But if you have multiple of the same key, the dictionary is not going to know which one you're trying to access, which is why you can only have one in the dictionary. Let's take a look at nested dictionaries. When you hear the word nested in programming, what you should always think is one thing inside of itself. So what this means is basically that when we have a dictionary, we can have another dictionary within that dictionary. So let's create a dictionary here. Let's create a code block. Let's call the dictionary personal info. And let's use braces to create the dictionary here. So let's say we have a value or a key name. And for that key, we have the value Eric. Let's say we have an age here. And for that age, we have the value 19. And we need to remember to add a comma to each input. So now, let's say we have a key phone. And what this key returns is another value. And a value can be anything, as can be a key. So why not, instead of putting another data type, a simple data type, let's put in a data structure. Let's put in a dictionary, another dictionary. And you can see Python doesn't scream at me because this is correct. You can actually do this. So let's say we have two different phone numbers, right? We have the home phone number, which is going to be this value here. There you go. And let's say we have the mobile phone number, which is going to be this value over here. And once again, always remember to add commas. And there we go. Now we have a dictionary with another dictionary inside as one of the values. Now let's say we want to access one of the values inside these dictionaries, these nested dictionaries. What we have to do, once again, create a print statement. Then we want to access personal info. And then we want to use the brackets here. Again, input the key phone. And what this is going to give us, a dictionary. So let's just print that real quick and see what happens. And as you can see, we have the dictionary here. So we access the entire thing. Now let's say I want to access one of these phone numbers. Similarly to a two-dimensional array or an n-dimensional array, you can just add another set of brackets here. And then you can add, let's say, phone, or so home. And now let's print this and see what happens. And we should get the home number, which is this number here, 1 through 0. Let's take a look at dictionary methods. Python offers us a variety of dictionary methods. We'll be looking at keys, values, items, update, and get,
as well as the pop method.
Let's take a look at keys. And what keys simply does is it gives you the keys in a dictionary. So let's look at this dictionary here, numbers. On the left, we have our key values. So this would be 1, 2, and 3. If we want to print those out, all we got to do is create a code block, use the print method. Then we want to access the dictionary numbers. We want to use a full stop to indicate that we're using a method now. And we're going to use the keys method. And let's print that out to see what we get. So to reiterate, keys gives us all the keys in a dictionary. So we should expect 1, 2, and 3 as integers. Let's print that out. And that's what we get, 1, 2, and 3, enclosed inside this. And what this is a view object, which is basically a list that contains all of our keys. If you want to actually use these values, you'll have to use something known as a loop. And we'll take a look at that in a later episode. Next, we'll be looking at values. And what this does, very simply, is returns the values in a dictionary, just like keys. It's a very similar method. So if we want to use this, all we got to do is use the print method. Then we got to input the dictionary numbers. Then we want to use a full stop to indicate we're using a method. We're using the values method. So then we put in the parentheses, press enter, and we get another view object with all of our values inside. As you can see, these are the strings spelled out, 1, 2, and 3. Let's take a look at the items method. And let's really quickly create another dictionary. So let's create a dictionary with movies. And we want to have different movie scores. So let's create a dictionary here. Let's say we have Jurassic Park. And that has a score of, let's say, 9.2. Now we have Shrek with a score of 8.4. And we have The Matrix with a score of 9.6. And let's save that really quickly. What items does is it returns a tuple with the key value pairs. So we'll look at what that means. Let's print this out. So print method, then we want to access the movies dictionary, full stop to indicate we're using a method. Then we're going to use the items method, and then we're going to print that to see what we get. And here we get a tuple inside with the values on the left, the keys, and then the values on the right here. So Jurassic Park with a score of 9.2, Shrek with a score of 8.4, and The Matrix with a score of 9.6. So it's basically like a combination of the keys and values method. And I should point out that this is not exactly a tuple. The item inside is a tuple, but the whole value, the whole data type is a view object. Let's take a look at update. Let's really quickly create another dictionary. Let's say we want to store prices of different items in a shop. And we're going to use a dictionary to store the name of the item and then its price. So let's say an apple costs for whatever currency you want. Let's say dollars. It's a universal currency. Then let's say we have bananas. And they are stored with a value of 75. Oh, 0.75. So I guess these would be cents then. And then we have milk. And let's say a carton of milk costs $1.50. I'm not sure how the economy is in the US. If this is accurate or not, I have no idea. So the way that the update function works is it allows you to A, update, so change or modify a value, and B, allows you to add a new value or insert a new value into the dictionary. So let's look at the first option. So let's say we want to modify or update a value inside of the dictionary. What we need to do is access the dictionary first, and then we use the method update. So full stop to indicate we're using a method on the dictionary, update, and what we want to do is we want to update the key value pair, basically. That is, let's say Apple, because we don't like the price of Apple, we want to make it more expensive. Let's say we want to make a little bit extra money. It's not making us enough money, so we want to update it. So what we want to do is we want to enter, using braces, the key value pair. So say Apple, and we want to update the price to Apple. Let's say we want to make it twice as expensive. This is not realistic by any means. I don't think you'd get this without extreme inflation, but we can update the prices of the Apple. And just to see what that looks like, let's print out prices at position Apple. So we can use it like that. And then we'll see, hopefully what we should get is the new value 0.8 instead of 0.4. And that's what we get. So the value actually changed from 0.4 to 0.8. And just so you can see what that looked like before, let me just delete this code block and run this again. And now if I print prices, the position Apple, it should be 0.4, which it is. So let's move on to the next app. So now let's say we want to add another key value pair to the dictionary. What we got to do is we got to once again access it. So prices, then we want to use full stop to indicate a method, and we want to update. What we can do is if we have another key value pair where the key doesn't exist in this dictionary, it's instead of updating it, it's going to add to the dictionary. So let's say now we use the braces. On the left, we have turkey sandwich. And a turkey sandwich costs, let's say, $2.50. And let's add that to the dictionary. And we can see if we added it or not by using the items method that we used earlier. And it's going to list out all of the items that we have. So you can see we have an apple with a price of 0.8, banana, milk, and then a turkey sandwich, 2.5. So we actually managed to successfully add a key value pair to the dictionary. We could actually also do this with nested dictionaries. So if you remember the personal info dictionary that we created earlier, we can actually access that, and we can access the dictionary inside it and update that dictionary. So let's go in here and let's say we want to access personal info. And we want to access it in the phone position because that's where our nested dictionary is, and we want to update that. And let's put in our braces. So we have a mobile address, we have a home address, and let's say we want to have a work address. So let's add this here, this key, work, and let's have a phone number just like so, and this is our work address, okay? So let's add that, and now let's print personal info items, just so we can take a look what this looks like. Or maybe let's access specifically phones, because that's what we're changing. Let's print this out. As you can see, we have our home number, our mobile number, and now our work number, which we just added. So that's pretty cool. So finally, let's say we want to update one of these phone numbers instead. So what we're going to do is very similar. We're going to access the dictionary, personal info. Then we're going to access it in the phone position. That's where our nested dictionary is. So we want to update. Let's say we change our mobile number, because that happens pretty often. So once again, we use the braces for a key value pair. Then we want to access the mobile number, and we want to add a value here after our key. So let's say our new value is something like this, just a bunch of random numbers here. And now if we print out, personal info, position phone, with a key phone, we see that our mobile number has changed from this number to this number. Very cool. Let's take a look at the get method. So let's really quickly use our dictionary from earlier, numbers. And what the get function basically does is it's another way of accessing the values inside of the dictionary. But there's a key difference. When you access it using the brackets, if you try to access an item inside of the dictionary with a key that doesn't exist in the dictionary, it will return an error. But if you use the get function, it'll just return the none type in Python. So let's take a look at what that looks like. So we have our numbers dictionary here. Now let's try and access, with our classical method, the key value pair of 4, which, as you can see, doesn't exist in here. So let's access numbers, section 4, and let's print that. Let's see what we get. So again, since we're using the brackets, we should expect an error to occur, and let's see what that looks like. And you see we get a key error because this key doesn't exist in the dictionary. We only have the keys 1, 2, and 3 as integers. But let's say we want to reduce errors in our program. What we can do, let's create a code block here, is we can access numbers, and we can use the get method, and we can try and access it with a key of 4. And let's print that one more time and see what we get. So what we should expect is that instead of getting a error, we get the none type returned. So we get none. So let's say we want to remove something from a dictionary now. All we have to do is go here, and we can use the pop method. And what this does, basically, is if we put in a dictionary, so let's say, let's use the numbers dictionary here. And what we want to do is we want to pop, and then we have to input the key. So let's say we want to remove 1. We can do that, and it will return the value as well. If we print this, if we print our dictionary, so that's numbers, and print the items inside, we should see that 1 no longer exists. So we only have 2 and 3. Let's take a look at sets in Python. If you remember anything from primary school mathematics, or if you're taking mathematics in college or in university, you might be aware of sets. And sets are basically, if you remember anything on Venn diagrams, for example, it's a range of values that can be represented, usually using some kind of notation like I or N, but they can be also notated using brackets. In Python, basically, what this means is we have a large set of non-repeating values. And there are a couple properties of sets specifically in Python that we're going to take a look at. So sets are non-ordered, similarly to dictionaries. There is no order to a set. Simply values exist in that set, unique values, so values that do not repeat. They are immutable, which means that you cannot update them during the runtime of the program. You can create a new set during the runtime of the program, but you cannot update an existing set. They are also unindexable. So values in this set do exist, and you can check them. You can check if they're in the set or if they're not in the set. You can use them to check if they're in other sets, or you can link them with other sets, but you cannot access them using an index, like you would in a list or a tuple, for example, or using a key value pair in a dictionary. So creating sets in Python uses a similar kind of notation to dictionaries. We use braces. So let's create a set 1, and inside let's have the values, we want to use an equal sign. We want to have the values 3, 1, 4, 5, 9. You might know these are the values of pi. And let's really quickly print the type, and we'll take a look at what that is. So you might expect a dictionary, but because there's no key value pairs, what we get is a set, as you can see. Another way we can do this is using the set function. And what this does is it returns a set of whatever you put into it. So let's say we want to say set2 is equal to, and we want to use the set function. Inside of the set function, we're going to put in a list, which is made up of 2, 7, 1, 8. And let's print the type of that real quick. And we should expect a set, hopefully. And that's what we get, a set. So when we have a set, again, one of the properties of a set is that all the values inside are unique. There are no repeating numbers inside of the sets, no repeating values. So let's create a set here. Let's call it unique, just to demonstrate this property. And let's create a set which has 2 zeros, 3 ones, and then 2 twos, and then 1 3, and then 5 4s. And let's really quickly print unique. And what we should get is because this is placed in braces, it's going to turn this into a set basically. And it's going to say, well, okay, we can't have any repeating values in here. So what we're going to do is we're going to take only the unique values and we're going to create a set out of that. So when we print this, we should expect to see 0, 1, 2, 3, 4 instead of 0, 0, 1, 1, 1, 2, 2, etc. And that's what we get, 0, 1, 2, 3, 4. So if you want to reduce a list, or if you want to reduce a set of values into only their unique components, then using sets is a great way of doing that. So you can create empty sets in Python, but you want to be careful with the notation that you use, and I'll show you why. So you can create empty 1 here, and we'll use the notation that we used earlier, which is with the braces, and we'll just put nothing inside there. So that's an empty set. And then we'll create empty 2, and we're going to use the set function, and we're going to put in an empty set of braces or parentheses here. What we should expect is 2 empty sets, right? So let's really quickly test that. Let's put in the type function, and let's test empty1 and see what type it is. And it actually returns a dictionary because this notation, these parentheses, these braces, sorry, are what we use to create dictionaries. So they have a higher priority when creating a new variable. But if we test type of empty2, which uses the set function, it should give us a set. So this is just for you to know, to be cautious. When you're trying to create an empty set, you should use this notation and not this notation. Let's take a look at set methods, and oh boy, there are a few. There's add, len, remove, pop, clear, union, and intersection. Let's start with add. So if you remember our unique set that we created earlier, which has the values from 0 to 4, we can actually use the add method. So unique.add to add a new value into this set. So let's say we want to add the value 5, and then we can print unique just to see what that looks like. And now we have values ranging from 0 to 5. And these don't have to be in any particular order. You can also add a value like 42, for example, using the add method once again. And we can see what that looks like. And we'll print that. And you can see we have 0 through 5 and then 42. And this method only takes one value at a time, so you can't add like 3 values at the same time. You can only add 1. And if you do try to add a value that already exists in the set, it's not going to change anything because there can only be one value, one of each value in the set. They all have to be unique. So now let's take a look at len, and this is very similar to the other length function that we would use. So if we just print len of unique, it'll basically tell us how many values are in this set, which happen to be 7. So 1, 2, 3, 4, 5, 6, 7, as you can see. Let's take a look at remove now. So let's say we don't like the value 42. Let's remove it because it just doesn't really make sense. We go 0, 1, 2, 3, 4, 5, and then 42. That doesn't make any sense. Let's remove 42 from the set. So unique.remove 42. And since every value is unique, there's only one of each value. It's not going to get confused as to which value to remove. So let's print that and see what that looks like. And as you can see, value 42 is gone. What the pop method does is, well, it's more of a function. It returns a value, and that is because it removes an arbitrary value from the set. So let's take unique one more time, and let's pop. Let's print this just to see what we get. Or let's print unique actually, so we can see the entire set. So what this is going to do is it's going to remove an arbitrary value, which means it can remove any value from the set. You don't know which value it's going to remove, and then you should be able to get that. So as you can see, remove the value 0. Now let's do that one more time. This time let's print the value that it removes. So print, and we want to get unique dot pop, and it should give us the value that it removes. So 1, it removed the value 1. So when we look at this set again, we should expect that only 2, 3, 4, and 5 remain. And if we really quickly create a code block and print unique, we should get 2, 3, 4, 5, which is exactly what we expected. Now let's say we don't like this entire set. So let's just take unique and let's clear it. Let's remove every value inside. And if we print unique after doing this, what we should get is an empty set. So it removes everything. So this is actually another method of getting an empty set, if you will. Let's take a look at union. If you remember anything about set theory, you can remember that you can actually apply a number of functions to different sets. You can do the union between different sets. You can do the intersection between different sets. There are a couple of other ones, but the ones we'll be looking at in today's episode are union and intersection in Python. So if we have a set 1, let's call it A maybe, it'll be easier to use later. And we'll use this notation this time. And let's have a bunch of odd numbers. So 3, 5, 7, 9, for example. And let's say we have another set B, and that's going to have even numbers. So let's say 0, 2, 4, 6, 8, right? And what we can do is we can create a set which has all of these values. So we'll call it set C. And that's going to be equal to set A dot union. So this is a function being applied to A, and we're going to do a union of A with set B. And let's print C just to see what it looks like. What we should be expecting is a union of both of these sets, which means that we have all the values in set A and all the values in set B. So we should see all the values ranging from 0 to 9, since that is the lowest and biggest number in our set. And that's what we get, 0 through 9. And now intersection, what this does is it basically returns the values that are only in both sets. So let's say if we have set A and set B, if set C was the intersection of A and B, we would have nothing, since there are no commonly shared values between both sets. These only contain odd numbers and these only contain even numbers. As we know, those are separate things, so nothing would actually come about from that. What we can do is test that theory. So C is equal to A dot intersection with B. And we can print C, and what we should get is an empty set, and that's what we get. So let's create 2 sets where we can actually test this hypothesis more clearly. Let's create A and B again. This time let's create 1, 2, 3, 4, 5, the first 5 numbers. And let's say B is going to be equal to 3, 4, 5, 6, 7, so from 3 to 7. And C is going to be the intersection of A with B. Now let's print C. And since C will have only values that are both in A and B, what we should expect is that overlapping values are in C. So in A, we have 1, 2, 3, 4, 5. In B, we have 3, 4, 5, 6, 7. So you can see 3, 4, 5 actually appears in both sets. So if we print C, we should expect a set with the values 3, 4, and 5. And do not forget to put commas between your values, because what I just inputted was the value 12,345 and the value 34,567. So make sure you put commas between all your values. And if we do this one more time, we should get 3, 4, 5. Awesome. Okay.
Hello and welcome to aorbtech. Today we are going to discuss conditional statement, and this is our 7th episode about Learn to Python series. And in this episode we will learn first if else conditional statement. After that we will briefly discuss match case. So let's start. Before moving to if else and match case, first we need to know what is conditional statement. Conditional statement is, in a simple way, if I explain that, is basically make decision based on the conditions. So let's say that if the weather is sunny, take the sunglass, and if the weather is rainy, take the umbrella. So if you see this example here, based on the condition we make a decision. So this is how conditional statement is work. So let's start with if else. Let's say that I take a variable which is weather, and let's say I'm going to take rain, and I say that if weather is equal to rain, then we have to say that bring umbrella, else print no need for umbrella. So how it's work? So as we know that in our data variable we declare rain, so we have a rain weather. So first it will check the condition, and if the weather is rainy, it will send the message that bring umbrella. If it's not rainy, which is like else, then no need for umbrella. So let's run, and it is said that bring umbrella. So how it's work basically? First, if you check if, and if is true conditions, then it will return the results. Otherwise, if the condition is false, then it will be run no need for umbrella. So let's take another example to explain you. Let's say that I am going to take sunny weather, let's say that, and if I print, it will say that no need for umbrella, because our condition was say that weather was sunny, but weather is rainy, so this condition is false and this condition is true. So if condition if false, then it will go to the second condition, which is else, and it will return the else condition, which is no need for umbrella. So this is how it's work. Let me show you another example. Let's say that we have weather, let's say that sunny, and I am going to print I will explain this code to you, and I say that alif sunny we're had, and after that I will say that. So what I did here, I take the weather as a sunny, as we know that our weather is sunny. So first it will check if condition, if condition is true, then it will print the result. If it's false, then it will go to the alif condition, which is sunny, and if he check this condition and it's true, then it will print the results. Otherwise it will return the else condition. So how it's work, like the weather is sunny and if weather is rain, so this condition is false, because as we know that the weather is sunny, and so this condition will false, then it will go to the elif weather is sunny. As we know that the weather is sunny, so it will print where ahead. So where ahead. So this is how elif is work. So let's say that our weather is let me copy this example, and I said that weather is snow. So let's say that our weather is snow. So what will happen? It will go to the first condition, weather is rainy. As we know that it's false, Then it will go to the second condition, alif, weather is sunny. Again it's false. Then it will return else. So it will say that no need a umbrella or a hat, as we know that the weather is snow. So this is how if alif else is work. So let's say that I show you another example. Let's say that I have number 10 and I said that if a is equal to 10, print card is greater, alif is equal to 10, print and else. So what we did here, we just declared another variable a and we stored a value 10 here. And we already discussed this topic in our data type video. So variable is just basically container which store a value, as well you know that. So what happened here, so it will check the first condition. If a greater than 10, it will say that a is greater than 10. So as we know that our variable is basically 10, so a greater than 10, which is false because 10 greater than 10 is false. Then it will go to the second condition, alif, it will say that a equal to 10, which we already know that a is equal to 10, and it will print alif condition and it will not go to the further. So a is equal to 10. Let's say that I wanted to a is equal to 11. What will happen here? This is true because a is 11 and 11 is greater than 10, so it's true. So it will run the conditions of first, and the rest of it will not go to the further as its condition is matched. So if I show you another example, let's say that a is equal to 9. So as we know that a is 9, a it come to the first if condition, 9 greater than 10, which is false. It will go to the second, alif, 9 equal to 10, again it's false. Then it will print the last statement, which is else, and a is less than 10. So here's go. So this is how if else is work. I can show you another example of nested alif. So let's say that I have a number, I'm going to take the same example, let's say that, and I say that a is equal to 10, and what happened here, so what I did here, I basically run another condition here inside alif, basically is nested condition. So if I run, it will return to print. So why, let me explain. So a is equal to 10, as we know that, so it will go to the first condition, so it's false. Then it go to the second condition, the condition is matched, 10 is equal to 10, so it will print this result. And then alif, we have another condition which we call nested, and so a module 2, basically it's if it's divided by 2 and equal to 0, it will say that even, because 10 divided by 2 is equal to the result is in module is basically a 0. So I can show you how it's work. So 0, because it's no it's written as a 0, so it's basically a is even. So let's say that I take another example. So basically first it will go to the alif, condition is matched, so it will return the result. Then it will go to the inside another condition statement. If condition is match, our modules a 10 divided by 2, which is 0, as we know that it's 0, so it's even, and then it's print the result a is even. It will go not go to the further. So this is how is nested conditions work. Let me show you another example. Let's say that a is equal to let's say 9, and let's say I am going to say that so if I say that so let me explain first what I did here. So I take a variable 9, and then I check if condition a greater than 10, which is false. Then it will go to the second condition elif, which is true, and it will print a is equal to 9. After that it will go to the inside nested if condition. It will check if a, which is 9, module 2 return 0, then it will say that even. Otherwise it will say that if it's not equal to 0, it will say that it's odd, else a is not a number. So what will happen? First it will go to this condition, it will print a is equal to 9. After that it will print a is odd, and that's it. So this is how if else elif is working, and this is how you can define your nested conditions based on your problem statement. So that's it for the if else use case. As we know that if very simple and straightforward, is basically make a decision based on the conditions. So if the condition is true in a if, then it will print, otherwise else. We have also have elif. It if is not printed, then it will go to the next elif, and after that it will go to the else condition. So this is how it's work. Let me show you another quick example. So let's say that a is equal to 10 and b is equal to 9. Just a quick demo. A is equal to, let's say that 10, and I say that let's say that, and I say another if condition. Let's say that I say another condition, which is 9, and then else a and b are not equal to 10 or 9. So let me show what I did here. So I basically try two if conditions, if and another if, after that else. So how it's work, let me show you. First it will return a is equal to 10, the first condition, which is already we know that a is 10, and then b is equal to 9, b is equal to 9. So it basically run both condition if. So in if condition, this is basically independent, and this is basically independent if statement. This is not dependent on this one. These are two basically dependent. So if we declare a multiple if condition, it will independent, it will not be dependent. If we say that another else statement, let's say that let's say that and I make condition false, so it will run this one because a is false. So these are different and these are basically different. These are independent, they are not dependent on this one. So this is one thing that I wanted to show you. So keep in mind, if you run multiple if condition, it will be independent instead of dependent. This is how I show you the example here, and this is how it's work actually. So feel free to write me in the comment section if you have any questions. And so let's move another topic, which is match case. Why match case? Well, first of all, maybe you heard switch. Switch is basically in other languages we are used, but in Python we have a similar match case, and switch is working same as match case is working in Python. First of all, the second is basically when you write match case, it will make your code more clean and more efficiently you can read, instead of you have a multiple if elif and else conditions will make your code is more confused. Second is better performance in some cases. Let's say that you are using loss of if else conditions, and instead of using this you using match case, and match case is basically work like instead of checking each conditions one by one, it will check based on the match, so it will faster and better than if else. The one thing that I wanted to mention here is match case. It was not this thing was not in Python before. This concept was recently came in Python 3.10 plus versions. As I am using latest version of current time, which is like I'm recording this video on 26 March 2025, and I am using my latest version, which is 3.11.9. So this was like came up 3.10 plus version. So if you are using 3.9 or 8 or below versions from this one, then you won't be able to implement match case. For that, you need to update your Python version, and then you need to implement this one. So let's start with the coding example. So let me show you the example of using match case. So let's say that we have fruit is a variable, and we store a value banana, and then I use match syntax and I write fruit. So what will happen, it will go it will check match is, as we know, that is banana, then we will define a case. So first it will go to the match, and then based on the case it will return the result. As we know that our fruit is banana, so first case, no, the second case, as we know that is banana, so it will return it's yellow. So this is how it's match case is work. Very simple, you just use the match syntax, and then you have to use whatever conditions, and then you want to specify your case. So I define here for multiple case, and our second case is true, so it return it's a yellow. So this is very simple and straightforward about match case, and it's just to be noted that the match case, it's a recent concept in the Python, and it's using in only 3.10 plus version. So to make sure when you use match case, you update your Python version, and the syntax is pretty much simple, match uh, and then case. So it's simply first it will go to the match, and based on the cases it will return the results. So that's it.
Hello everybody and welcome to another installment in the Learn to Py series. Today we'll be taking a loop at loops. In this episode, we'll touch on while loops, for loops, the range function, jump statements, and list comprehension. So let's start with what a loop is. A loop, otherwise known as an iterative statement, is essentially a block of code that repeats a known or unknown number of times. These are the two basic types of iterative statement or loop. When you know how long a loop is going to last, it's known as a definite loop. But when you don't know how long it's going to last, it's known as an indefinite loop. What this all basically means in layman's terms is that if you have a block of code that you want to repeat a certain number of times, you can do it using a loop. In programming, loops are super useful when you want to complete a repetitive task multiple times, or if you want to access multiple elements inside of another element. So we can do that using loops. Starting off with while loops. While loops work in a very simple way. There is a syntax using while. You have a condition, a colon, and then you have some code that you want to repeat. What this basically means is that in Python, if you want to have a block of code that you repeat given a condition, so given that a condition is true, given that a number is greater than another number, given that some statement that you've created is true, or given some other condition, the loop will repeat over and over until that condition is no longer met. So while something is true, do this. And then if it's still true at the end of the code block, then go back to the beginning and do it again until it's no longer true. That's basically what a while loop is. So let's create one really quickly just to show you an example. So let's create a block of code really quickly, and let's define a number. Let's call it num1. Let's say it's equal to 0 for now. And now let's create our first while loop. And let's say we want this block of code to repeat until number 1 is no longer smaller than 10. So as soon as number 1 is greater than 10 or is equal to 10, this condition is no longer met. This condition is no longer true. So this loop will repeat while number 1 is smaller than 10. That's basically what we're saying here. And while number 1 is smaller than 10, what we want to do is we want to print number 1. So we want to see what value number 1 is. And we want to increase number 1 by 1. So we want to increment it by 1. So we want to say number 1 is equal to itself plus 1. And let's go through this really quickly just to see what's going to happen. Let's try and make a prediction. So number 1 starts off with the value 0. Then we enter the while loop, and the condition is that number 1 is smaller than 10, which is true because number 1 is currently 0. What this is going to do is it's going to put us into the while loop. So we're going to execute this block of code, and then we'll check against the condition again at the end. So first we print number 1, so we'll print 0, which is the current value of number 1. Then we're going to say number 1 is equal to itself plus 1. So number 1 is equal to 0 plus 1, so it's going to become 1. Now we go to the beginning of the while loop again, and we check for that condition that we had earlier. So is number 1 smaller than 10? Well, the current value of number 1 is 1, which is smaller than 10, which is true. So then we continue and redo this block of code. So we print number 1, so we print 1, and then we say number 1 is equal to number 1 plus 1, which is 1 plus 1, so we'll get 2. Is 2 smaller than 10? It sure is. So we print 2, and then we add 1 to 2, so we get 3. Is 3 smaller than 10? It sure is. We print 3, then we add 1, so 4. Is 4 smaller than 10? Yes, print it, and so on until we reach 10. So let's say it's 9, we add, and since 9 is smaller than 10, we'll enter this loop. Then we'll add 1, so it becomes 10. Is 10 smaller than 10? It sure isn't. 10 is exactly equal to 10. So we will no longer enter this loop. Again, we will not print 10. We'll just exit this area and we'll go into a new area. Whatever comes after the while loop is what we're going to do. So let's run this code and see what happens. So what we should expect is it to print every number from 0 to 9, but not 10, because the condition wouldn't be met, wouldn't be sufficient for us to enter the loop a final time. So let's see what happens. And as you can see, we print all the numbers from 0 to 9. Just to show you something interesting, if you create a while loop, note that the while loop will not stop unless the condition is false. So if we just write while true, we'll actually get an infinite loop. And I'll just quickly run this to show you that this will run forever. So you'll just get a bunch of infinites printed out. Let's really quickly explore why this is true. When we enter a while loop, we first check a condition. So true, well, that just returns true. So we enter the loop, we print infinite, and then we go to the beginning. And since this will never change, it's not a variable, and it doesn't change during the runtime of the code block, this loop will go on infinitely. And this can mess with your memory. So make sure that you check in your code if you're accidentally creating an infinite loop or not. I'm just going to run this just to show you guys what it's like. And it'll just keep going forever. So as you can see, it's not stopping, and I will have to interrupt this not to break my computer. But eventually this will cause some issues in your code. So just be wary that this can happen. We can do the same with false. So if you see, we'll never actually enter this loop here. So let's say we print false here. This will never actually be printed. Let's print something else here. Let's say print else. I don't know. Let's go through this. While we'll check the condition false, returns false. Since this condition isn't met, we'll just skip over to this case over here. So this will never actually print false. It'll just print else. And my IDE has kind of faded out this text. You can see it's never going to happen. And you see we don't print false, we just print else. So I wanted to show you a really cool and common use for a while loop. So let's say we have a password that we want our user to input. And let's say we have a minimum length for our password. And so we're going to use a while loop, and we're going to say while the length of the password is smaller than, let's say, 8, for example. And we're going to prompt the user to write the password again. We're going to say, we're going to print, and we're going to use an f string here. We're going to enter the password here, variable, and we're going to say password is too short. Please input a new password. There we go. And once we exit this loop, we're going to print the user's password. So print your new password is, and then the password variable. So let's see what happens here. Let's run this. What we should expect is that we ask the user to enter the password. If that password is smaller than 8, the length of that password, so how many characters are inside it, then we'll enter the loop. We'll print password is too short, so the variable, the password, whatever the user enters, and then we'll prompt the user to enter a new password again. And if we exit the loop, so if the password has a length greater than 8, so if there are more than 8 characters, then we'll say your new password is, and then the password. So let's run this and see what happens. So right now it's prompting me to enter a new password. So let's enter something like ORB, which is only 3 characters long. Let's see what happens. And it says orb is too short, as you can see here. So I'm going to enter something else like Python. Python is also too short since it does not have 8 characters. Now let me write aorbtech. And aorbtech does have more than 8 characters. So it exits the loop and it says your new password is aorb. Okay, that's pretty cool. So let's see what happens if we, from the first pass, we enter a password that already has 8 characters. So what we should expect is, since it already has 8 characters, we never actually enter the loop, and we just print the new password. So let's run this one more time, and let's enter aorbtech again, since we know that that has more than 8 characters, or at least 8 characters, and let's see what happens. So as you can see, we never get this text because we never enter the loop. We just get this text at the end. So we kind of skip over this whole code block here. And we just get your new password is aorbtech. So that's pretty cool. So let's say you want to iterate over a list. Let's say we create a list here. Let's say list1 is equal to, and then we'll have a list inside. I'll have a couple of elements, let's say year 1, year 2, year 3, and so on. You can see how this would go. Let's say year 4. We'll do up to that. And now let's say we want to go through each of these. Remember that a list is made up of a bunch of elements inside, which each are accessible using an index, right? So if we wanted to access, let's say, year number 3, we know that indexing starts from 0, so this would be the 0th element, this would be the first, and this would be the second. So what we want to do is we want to print using the list1 variable, and we want to access it at position 2, because that's the third element, and we're going to print that really quickly, see what we get, and we get year 3, which is what we were expecting. So if we wanted to access each of these, we would need to access each of them at their indexes. So 0, 1, 2, 3. Notice how each index is one greater than the last. And we can use loops basically to have an index variable. We're going to start it at 0 since that's the first index. And let's say we increase it by 1 each time, and then we print the element each time. So at that index. So let's create a while loop here. Let's say while index is smaller than the length of list1, since we don't want it to go past our limit, we know that if we were to try and access this at position 4, even though it says year 4, we know that this element would be at position 3, since indexing starts from 0, so we shift everything by 1 to the negative direction. If we try to access this at position 4, we would get an error. So let's make sure that we account for that by not exceeding that limit. We're basically saying while the index is smaller than the limit, which is 4 in this case. And what we want to do is we want to print the element, so list1 at position index, since we know that'll be the element we're trying to access. And what we should expect is when I run this loop, it is going to print year 1, year 2, year 3, year 4. So the element at position the index. So the index is 0, and then we increase it by 1, and that's the key thing here. We need to say index is equal to index plus 1. So this increases each time the loop runs. And so we go back to the beginning of the loop, it's still smaller than 4. Let's say it's number 1 now. We print at position number 1, so year 2. Then we increase it by 1. The index is now 2. We go to this condition, is it smaller than 4, since that's the limit again, remember? And so it is still smaller. We print list at index position 2, so year 3. And then one more time we increase it by 1. We get 3. It's smaller than 4, so we print the fourth element, or the element at position 3, index equals 3, which is year 4. And then finally we increase it by 1, it'll be equal to 4, and 4 is not smaller than 4, so we'll exit the loop. And so let's run this just to see what we get. And yeah, we print every single element in the list. That's pretty cool. So let's take a look at for loops. What is a for loop? Let's try and explain it in a simple way. A for loop in Python visits every element or every item inside of an iterable object. What is an iterable object? An iterable object is something that has more than one element inside it. And a for loop allows us to access each of those elements one by one in a specific order. It has this kind of syntax, which is for item in iterable object, and then the code that we want to repeat. So this code will repeat for every item in iterable, or in the iterable object. This could be a list, it could be a tuple, it could even be a dictionary or a view object, and it can also be a range, which we'll take a look at in the next part, in the next section. So let's say we have a list here. I've created a list containing the spelled out first 6 numbers starting from 0, so that's 0 to 5. And let's say we want to print each one of these in the list. So each one of these strings here are an element of an iterable object. This list is an iterable object because we can iterate over each of the elements inside it, each of the items inside it. So let's create a for loop here. And let's say for number in numbers, and numbers is the name of the list we have here, and then we'll put a colon here. What this is essentially saying is for each of the variable number, so we're creating a new variable to reference each of these elements. This is referencing, for example, 0 or 1 or 2 or 3, depending on where we are in the loop. So for each of these elements in the list, numbers, and this is the list here that we have defined, and then we have a block of code that we're going to repeat for each of those, so for each of the numbers. So let's say now we want to print and we want to print number. And remember that number is a variable we've created in the loop which references the element that we are currently viewing inside the list numbers. So since we're referencing, let's say, the first element, it should print 0. And since this is going in order, it'll then, at the end of the loop, go back to the beginning and it will say, are we at the end of this iterable object? No. We still have yet to finish. So let's go on to the next one, which is 1. Then we print it. We go back to the beginning. Have we visited until the end? No. So let's print 2. And we carry on printing each of these until we reach the final element. Then we'll print that final element. And since we're at the end of the iterable object, we're going to finish the loop and continue to whatever code you might have afterwards. So let's run this. We should expect that each of the elements is printed one by one. Now let's see what happens. As you can see, each of the elements from 0 to 5 has been printed. So remember in a previous episode, we said that we can access the elements inside of a dictionary using a view object. So we can look at them in the program if we want to, but we can't actually access them. We can do this using a for loop. So if we write for, I've created a dictionary here with names and surnames. And so we'll have for, and we have the key and the item here, or key value. Let's use this terminology. In name, surname, and that's the name of our dictionary. And we're going to print, and we're going to say we're going to create an F string. We're going to say key, and we're going to add a colon there, and then value. And so what we're doing basically here is let's create dot items. So we're accessing the dot items of the dictionary, the items of the dictionary, and remember this returns a view object. We're saying for each key value pair inside that view object, and we're separating them into different variables here. And then we're going to say for each of those, execute this code. And what this code does is it prints out the key on the left, followed by a colon, followed by the value on the right. So what we should expect is for each of these to be printed, each of these name surname pairs. So let's see what happens when we run this code. And as you can see, we can indeed access each of the values inside of this view object using this for loop. So as you can see, these names are being printed out. Very cool. So let's talk about the range function. The range function is a very useful function in Python. It basically returns a sequence of numbers. That's it. It follows this format, so range, start, stop, step size. So this is the range that you want to visit. This is from the beginning to the end, non-inclusive. That's another thing to note. And you don't actually need to write start and step size. Those are optional. You can just write stop, and it'll automatically write from 0 to the stop number, so to the end number. And this can be useful in lots of different situations when you need to access a specific sequence of numbers in a specific order, following a specific rule, for example. And I'll show you how you can use it below. Let's really quickly look at the simplest example that we can with the range function. So let's create a for loop. Let's say we're creating a variable value for value in, and then we use the range function, and let's say 10, right? So we put a colon and we print the value. What is this doing? What does this mean? First of all, we're creating a for loop. So when we create a for loop, we know that we're going to iterate over some kind of iterable object, and we're going to store each of those elements in each iteration of the loop inside this variable value, right? So this variable represents each of the elements inside this, whatever's over here on this side, right? So range, what does that return? That returns an iterable object with a sequence of numbers. So it returns the next number in a sequence each time, starting from a specific number. In this case, we're doing the range with the parameter 10. What this basically means is the numbers from 0 to 9, since this is non-inclusive. So what we should expect is, since this represents each of the elements inside of this iterable object, inside of this range function, what we should get is the values from 0 to 9. And since we're printing each of those values in each iteration of the loop, each pass of the loop, each time we go through the loop, each time we go through each of the elements, we should expect to print in order the numbers 0 to 9. Let's see what we get if we actually run this code. We get exactly what we described. Each of these represents an element in this object here that we get, in this iterable object. So what range basically defines is a series of numbers, not a list. Don't get it confused with a list. It's a separate entity from that. It is an iterable object that returns the next element in a sequence of numbers. In this case, we start with 0. The next element would be 1, then 2, then 3, all the way up to 9, since that's what we defined in the beginning. Remember that 10, that's non-inclusive, so it's all the numbers up to 10, but not including 10. So let's look at some extra examples of this. It can seem a little daunting and difficult at first, but it's actually super easy as long as you understand what's going on. Let's try using more parameters. So let's create a for value in range, just so we get used to this, in range, and then let's say we want to access the numbers from 18 to 65, and we want to step by 1, right? So then let's print the value, and what do we get? All the numbers from 18 to 65, not including 65, remember, not including 65. Let's do a new code block. Let's create a for loop, and we want to access the values in the range. And let's say we want to print all the even numbers from 0 to 10. So starting from 0, and since we want to include 10, let's say 11, because that's the first number after 10, and it's not going to be included as well. And since we want to print the even numbers, we should step by 2. So let's see what this looks like. Of course, we want to print the values. Oh, and that's what we get. So 0, 2, 4, 6, 8, 10. Awesome. So now that you know kind of how the range function works, I've created a list here with all the ordinals in English up to 5. So first, second, third, fourth, fifth, right? And let's say we want to print each of these. So for value in range, and let's say since we want to access the items in the list, let's instead call this index, because we'll be referencing the index of the list, right? So for index in range 0 to 5, right? Since we know there are 5 elements inside of this list, and we want to access from 0 to the fourth, since indexing starts from 0, we'll index in range 0, 5, and you should know that by default range uses 1 as the increment value. And we're going to print the value of ordinals, so that's our list, at the position index. There we go. So what does this mean? Let's take a look at this. We're iterating through the values 0 to 5, and we're storing that in a variable index, not including 5, so 0 to 4. And then we're printing the list at position index, so 0 to 4. We're printing the list at those indexes. So the values, the elements at the indices 0 to 4. So those are the first 5 numbers. What this means is that we're going through this list and we're printing each of the elements basically from the positions 1 to 5. Or if you remember that indexing starts from 0, 0 to 4. So let's actually run this and see what happens. And as you can see, we get each of these printed out. So let's quickly take a look at another example. I've taken our numbers list from the previous examples. I'm going to start another code block for index in range. So again, this means that we're creating a variable called index, and we're doing it in a specific range from one number to another number. So we're visiting all the numbers in a sequence. And now we need to define the sequence using the parameters for range. Let's say we want to access the first 4 of these. So there we go, we put in 4. And what we want to do is we want to create an F string here, print, and we want to print the index. So we want to see what this value is, and we want to see the element in this list. So we're going to print numbers at the position of index. So we'll get to see what the index is, and then what the element is of the list here using that index. So we'll get to look at both variables. And we're doing this for the first 4 elements. Let's print and see what happens. So we get 0, 1, 2, 3. Those are 4 elements. We can increase this up to 5 or 6 since there are 6 elements. Let's see what happens. We get 4, 5. If we try and do any higher than that, let's say 7, then we should get an error. Since we're trying to access elements that do not exist in the list. We go from the index 0, 1, 2, 3, 4, 5, and then we try to access the 6th, because this is non-inclusive, remember, so it's all the numbers up to 7. So we do 6, and since there is no 7th element, or an element with the index 6, we get an error here, an index error, which basically means that we try to access something outside of the range of this list. So jump statements are a special kind of statement that go inside our loop that allow us to fulfill extraordinary situations. So let's say we want to skip over a specific iteration, or if a specific condition is met, we want to end the loop entirely, but it doesn't have to do with the original condition that we have for the loop to end, so we just want to add that in there as well. Or let's say we want to have something that happens if the loop never starts to begin with. So these are some extra things that we can add to spice up our loops. Let's take a look at else. Let's say we have a while loop here. Let's say num1 is equal to 0 first of all, and let's say while num1 is smaller than 3, print num1. First, let's increment it. So num1 is equal to num1 plus 1. Oh, and another way you can write this. So there's this statement here. Let's comment this. You can say num1 plus equals 1. So these two statements are equivalent. So this is the same thing as this basically. Each time we increment num1 by 1, and then we print num1. Now let's put an else here. And let's print over. Well, let's print false for now. Let's just print false. What this is basically if the condition is not met. Let's see what happens if we run this really quickly. You can put your guesses in the comments below. So as you can see, we go through the loop normally. We go from 1 to 3. So since we're incrementing first, num1 is 0, but since it's smaller than 3, we enter the loop. First we increment it, so now it's 1, then we print it. And then we keep doing this over and over until we reach 4, at which point we print, once we finish this block of code in the while loop, we continue to this block of code here, this else statement, and we print false. So what this else basically is it's a block of code that happens when this condition here is not met. That can be at the beginning of the loop, or it can be at the end of the loop. But when this condition isn't met, we finish doing this code, and we move on to this code over here. Okay, this one is super useful. This is break. Let's say at some point during the loop, we want to check if a certain condition is met, and if it's met, we want to stop the loop entirely. So let's create a for loop really quickly. So for value in range, let's just say we want to visit the first 10 numbers from 0 to 9. Or maybe let's spice it up from 1 to 10. And we want to say print value. And let's say if value is equal to let's say 7, we want to break. And what this is going to say is we want to print each of these values, and then we're going to check for this condition. If value is equal to 7, then we break. So we exit the loop. And let's quickly just see what happens. Let's run this. And we get 1, 2, 3, 4, 5, 6, 7. So we go all the way up to 7. So as you can see, we still print the value. We go through all of these. And then as soon as we notice that the value is 7, we exit the loop. So we never actually get to end up printing the rest of the values. So that's really cool. It's really useful in a lot of different situations. Continue is similar to the previous two, or similar to the previous one, except it continues the loop, it just skips a certain scenario. So let's create another loop. For value in range, and let's say 15, why not? Now let's say we want to print every one of these values except for those divisible by 3, right? So let's quickly say if value mod 3 is equal to 0, and what this basically means is this operand here gives you the modulus of the 3. So let's say this was a quotient, we would get the numerator. Basically what we're saying is if the operation of dividing the value by 3 gives us a remainder of 0, so no decimal points, then we should continue. So we should skip over this iteration. And then we're gonna write print value. So if this code executes, we're gonna skip this iteration of the loop, right? And this block of code, in layman's term, just means if value is divisible by 3, if it is a multiple of 3. So if we have a multiple of 3, skip this iteration and go on to the next one, right? And for every other iteration where it's not divisible by 3, we print the number. So let's see what happens really quickly. And as you can see, we print 1, 2, but 3 is nowhere to be seen. We go straight to 4, 5, then 6 is missing, 7, 8, 9 is missing, 10, 11, 12 is missing, 13, 14, 15 is missing. So we print all of the numbers except those divisible by 3. So that's a really cool application of this statement. Okay, this one is mainly useful when you're writing code and let's say you don't have enough time to finish it, so you need to pack it up for a little bit, but you don't want it to cause any errors in the meantime while you're doing other code. So you move on to something else, and you don't have time to finish this code. So let's say you just have a for statement here. Let's say for value in range 5. So, and let's say you have some idea here like print each of the values or something like that, and you don't have time to implement this. If you try to run this code by itself, it'll cause an error. It'll cause an error which will mess up the rest of your program. It'll cause a lot of issues. So what you can do here is you can use parse, and what it'll do is basically saying, okay, so I want to have a for loop, and I'm going to put some stuff in here eventually, but for now it's kind of empty, but I don't want any errors to happen or anything like that. So I'm just going to put this pass statement here, and what your Python will do is it basically says, okay, we'll let you free on that one. We're not going to cause any issues, but you've got to implement it in the future, all right? So this is kind of just like placeholder code. Like you'll put something in here eventually, but right now you just don't have anything in there. So list comprehension is something super useful that I don't see in enough tutorials online. So a lot of newcomers to Python, they won't know how to use it, but it's super useful. And it's basically a simple way of creating lists with predefined values. Let's say we wanted to create a list with just a bunch of zeros inside it, like specifically 10 zeros or 15 zeros or however many zeros you want. Or let's say we wanted to create a list with all the numbers from 1 to 100, for example. There's no like intuitive way to do it, right? So this is just a really cool way of doing it. I'll show you how to do this. Let's say we have a limit here, or let's say we have a size, let's say, and that's going to be equal to, for now, 10, right? What we're going to do is we're going to say zeros is equal to, we'll create a list, so whatever's inside of these brackets will become a list, and let's say 0, because that's the value we want to do, for, let's say value in range, and then the size, whatever the size is that we created. What this basically means is that we're going to put in the value 0, and we're going to do it for every value in this range. And then let's print zeros. And let's see what we get. And as you can see, we get a what I would call an empty predefined list. So it's a list of just a bunch of zeros inside of it. And you can set these to whatever you want. And this follows a specific format. As you can see, we have an output here. This is what we get. This is what we get as the actual value of each of the values. We get a range, kind of like you could say, you could use another list as this, for example, and then you have a condition at the end, which we didn't put in this case. Let's create one with a condition here. Let's say we wanted to create every even number from 0 to 10. So let's say even 10 is equal to, we'll create a list here, and we're going to say value. So we're creating a variable value here for every value in the range 0 to 10, and since we want to include 10 and it's non-inclusive, we'll write 11. And we could do it like this. We could use a jump statement. Let's just see what we get using that, or a jump parameter in our range. And let's print even 10. See what we get. So we get all of the even numbers from 0 to 10. But let's say we don't want to use this parameter. We could say if value mod 2 is equal to 0. And again, this is just the remainder. So if the division of value by 2 gives us a remainder of 0. So if the value is even, and since we have this condition, now if we try running this, we should get the same result, all the even numbers from 0 to 10. So let's say I have a list here, and I have a list of fruits, right? Let's say I wanted to get every fruit that starts with a particular letter, right? So let's create a new list here. Let's say starts with, and then let's pick a letter, I don't know, let's say A, for example, starts with A, is equal to list, and let's say value for item in fruits, or let's say item for item in fruits. So we're creating a variable item, and it's going to be the elements in fruits of the list fruit. And then let's say if item dot starts with, and this is a function you can use for strings, and let's say A, right? And maybe just to make this more understandable, let's say fruit instead of item. So if for each fruit in the list fruits, we want to add it to this new list if this condition is met, which is that the fruit, the variable that we're checking, so the element inside fruits, starts with the letter A, right? Let's run this and see what we get really quickly. Let's also make sure that we print the new list. So it starts with A, and let's see what we get. And as you can see, we have a new list with elements or with fruits that just start with the letter A. And let's quickly go through this. We get apple here, we have apricot, and then we have avocado. And as you can see, those are the ones that we have in our new list. So this is a super useful tool that you can use in your programming.
Hello and welcome to aorbtech. Today we're going to discuss continuous series of Python line to Pi, and this is our another episode about function and recursion. The agenda of today will briefly discuss how the function is work, how we can create and make our own function. Also we'll briefly discuss a recursive function as well, and we'll give some proper example. So let's start with it. What is function? A function is basically a block of code that perform a specific task, and this task can be reused again by just calling the function name. Let me give example. Let's say that I wanted to build a calculator, and I write the function name is calculator, and I write some instruction. Let's say that addition, subtraction, multiplication, and so on. So when I wanted to use this function, I just call the name of the function by passing the parameters values. It will take some arguments and it will run. So let me give you a simple example without passing any arguments and parameter. Very simple. Let's say that I wanted to take a function, and by writing the function you just write def, and the name of the function, let's say that I wanted to write function which name is greeting. After that I write some instruction. Let's say that I wanted to welcome to aorbtech and I run this function, and so this is my function. So I write the function, the name of the function is greeting, then I write instruction. Here I just write one line of instruction, welcome to aorbtech. Now I want to call the function and it will return my results. So greeting parenthesis and welcome to aorbtech. So this is how the function is work. Instead of repeating your lines every time and getting the output, you just write inside the function of your instruction and just recall your name of the function. It will return your results. Let's say that I wanted to recall another time and welcome to object. So fantastic, this is how the function is work. Type of function, there's a two type of function in Python. The first one is built-in function. Built-in function is already present in the Python. Let me give an example. So let's say that I have a list of number and I say that 1 2 3 4 9, and I wanted to use built-in function and I return my results, and it's 5. So this function that I used here, len, is a built-in function. So they have a more example in built-in function. Let's say that print, sum, len, these function are built-in function. The second one is user-defined function, which created by user. So we already create a user-defined function previously, this one. So we write a function name is greeting, and we just writing function welcome to aorbtech, and this is the function. As we call the function, it will return welcome to aorbtech. So this kind of function is basically user-defined function. Let me write another function to understand. Let's say I want to do farewell and I wanted to goodbye aorbtech, and let's run, and I just recall my function, so it will say that goodbye from aorbtech. So this example is the user based function because it's created from the user. So this is how we can create our own function. So these are two examples basically that we understand here. One is built-in function, which already present in the Python. I gave one example using len function, and the second one is basically created by user. So this function is basically user-defined function. I hope it's clear for you. Function with parameter and argument. So parameter is basically a variable listed in the function definitions, and the argument is basically the actual value that you pass to the function when calling. Let me give an example to understand what is parameter and what is argument and how this concept is work in this example. Let's say that I wanted to write a function, and let's say that greeting function, and I take one parameter, the name, and I said that print the value. So what's here? Here I write function greeting and then I pass parameter. This is basically a parameter. If I hover on it, you can see, and this is basically parameter, and I doing welcome to aorbtech and the name that I will write, which will print later. So now I'm calling the function. My function is greeting and I am passing arguments. So whatever I passing here, the value, actual value, when I calling the function, this is argument, and I write on the definition. So let's say that I want to argument Eric, and if I run this function, it will say that welcome to aorbtech Eric. Now I wanted to say someone else greeting. Let's say that I would so I say instead of Eric I say that Amir, and if I run my function it will say that welcome to aorbtech Amir. So I write my function and I take one parameter here, and then I just call my function and I pass the value. The value that I'm passing here we call argument. So I just pass my argument Eric. It will call the function, it will print the results, it will say welcome to aorbtech, same as greeting Amir as well. So this is how parameter and argument is work. Before moving forward with parameter and argument with few example, let me quickly explain differences between return and print here. Let me give example. Let's say that I want to take the same example here. First I will explain about return example. So as you know, I already defined my function. Function name is addition, then I pass my two parameter, then I am adding these two parameters values, and then I return these results. I run my function. Now let's say that I just call my function. Let's say that I want to define my function name is like a is equal to addition 3 3, and then I will print a and it will return the 6. So let me give the example of print and then I will explain how it's work. So instead of taking return here, let me take print example and I run my function here. Now let me define my function additions 3 plus 3, and as soon as I run it it will return 6. If I print my b it will return none, but if I print my function which I call return a, and it will return 6. So in a return is basically as soon as we return the results to the function, then we define the function until we print the result, then we will get it. But in print, as soon as you define the function, it will return the results without calling a b. So that was a quick concept, differences between return and print. Sometime interview asks this question, and this is a very popular question to be honest in that case. Now I'll explain function with default parameter. This is our next example while using parameter and argument, and this concept is also used while when we are making and writing function. So let's say that I wanted to write my function and I wanted to multiply some values. Let's say that my function name is multiply, and I wanted to take num1, num2 and num3, and I wanted to multiply all the values here. So I multiply 3 values and I return my results. So now I will call my function here. My function name is mul and I am passing my 3 value 2 3 4, and if I return the results it will 24. How? 2 multiplied by 3 6, 6 multiplied by 4 24. So here it works. Now I said that default parameter. What does it mean by default parameter? Let's say that I already define my parameters values. Let's say that I want to take 2, num2 value is 3, num value is 4. If I run this function, what I need to do, I just need to just define or call my function, and it will return the results 24. So this is how we can write default parameter. Let me show you another example. This is my default parameters. If I don't pass any argument, it will, based on the default parameter, it will return my value. Let's say that I want to pass some argument, then what will happen? Let's say that I wanted to pass my one argument here. Let's say that I wanted to pass 5. What will happen? So when I pass the value 5, let me show you the example. So when I pass the value one argument, although we have a 3 parameter, it will override with the first parameter. So 2 replace with 5, so 5 multiplied by 3, which is 15. 15 times 4, which is 60. So this is how defaults parameter is work, and this example here is basically I'm overriding the value here. So let's say that I wanted to call my function again, and I wanted to override two value, 1 and 1, and if I return my results, what will happen? 1 will override with 2, 1 will override with 3, 1 multiplied by 1, so 1 again multiplied with 4, the results will be 4. So this is how the default parameter is work. Either you can write by default parameter, either you just simply write the name of the parameter and passing the values in the argument that I show you a few examples here. So that's it from the function. I hope you understand the concept very well. If you have any doubt, feel free to write in the comment section. In the function, let me recap the concept again. Function is basically a block of code that perform a specific task. Writing the function, we just write def and the function name, and by calling the function name we get our results. There's a two type of function. One is built-in function, which is already in Python. The second is user-defined function that we write here farewell, and there is like function with parameter and arguments. Parameter is basically value listed in the function. Argument is basically actually that you passed to the function when calling it. So this is the parameter here, and this is the argument here. Hope this example is clear for you. Then we also see the difference between return and print. There's a minor concept here. This is mostly useful when you're writing the function. Mostly when we're writing the function, we always use return, but some in cases we also use the print case as well. Then we also see a couple of example with default parameter. Either we can write by default parameter if needed, otherwise we can passing our value in the argument, and those value will take overrides. So this is how the function is work. And the next topic is a recursive function. A recursive function is basically a function that call itself to solve the problem. It's like more about mathematical equation. Think like a mathematical equation where you just write the equation and put your value and get your answer. So in function, recursive function, it's basically split bigger problem into smaller part and make until it's easy to solve. So let's say that I wanted to write my function factorial, and how I write my function: if num is equal to 0 or 1, it will return 1, otherwise it will return this equation. This equation is more likely to factorial equation. So let me explain further. Let me write my run my function, and Now I will call my function, and so that I will call 5 and 120. How I get 120 here? Let me show you with brief example. So this is how it's work. So you write the function factorial, and this is more likely factorial equations. So when you pass argument 5 value, what will happen? It will go to the function. This equation is false, so it will go to else condition. What's going on else? 5 then multiply factorial 4. How 4? Because it will subtract minus 1. So 5 minus 1 is equal to 4. So it will become 4. And this 4 will call to the function again factorial 3. 4 multiply factorial 3. And then again it will call factorial 2, factorial 1 and 1. So when you have factorial 1, this condition will true, we get the value 1. After that it will return the result. So 1 multiply with 2, then multiply with 3, like in a back way multiplications, 4 and 5, and then it will return the results. So this is how our recursive function is work. I hope it's clear. It's more likely a direct way of writing the function, and the idea is basically when we're using this function basically is calling the function itself, as I show you how factorial is subtract every time minus one number and then calling until it's become a smaller part and solve, and then it will backward multiplication and get the results. So this is how it's work. I hope it's clear. If still have any doubt, feel free to write in the comments and we'll try our best to answer. That's it for today's video. Today we briefly discuss function and recursion. We also see a few examples about function and recursions.
Hello everybody and welcome to another episode in the Learn to Pi series. Today we're going to be looking at file types, opening files, reading files, file modes, writing to files, and the with statement. So before we actually start messing around with files, we need to know what a file actually is and what it does. And to simplify quite a bit, as programmers, there are two main types of files that we like to deal with. Technically, everything is a binary file because everything in a computer is encoded using ones and zeros. But as far as programmers are concerned, there are two main types of files, those being text files and binary files. Text files contain information that can be rendered as text, that can be broken down with new lines, and that doesn't have a null character, for example. And binary files are other kinds of files which can store different types of data. For example, an MP4 file that stores a video, or a PNG file that stores an image. Text files usually have the extension of .txt or .md. So let's see how we can open a file in Python. All we got to do is create a variable, let's call it file, and we're going to use the open statement. We're going to put in the file name. In this case, let's say test file .txt, and this will be a text file. And then we'll just type this little symbol here, and this will be our mode. And I'll explain what that is a little bit later. But essentially, it's going to open our file, and then we can print that out and see what the output is. As you can see, it returned this, which is our file that we opened. Whenever we open up a file in Python, it is good practice to close the file after you finish using it. This is so that we don't take up too much memory after the program is done. So we can do that because we have our variable here. We can access it and we can use the close method. And if we run that, it will close our file, and that won't be hogging up memory anymore. So as you can see, I've created a test file, which is a txt file. It's in the same folder as my Jupyter notebook, and I'm going to be using it to test out file reading in Python. So this is the text. Hello everyone, this is a text file made for testing purposes. Let's go back to our Jupyter notebook, and we're going to be testing out reading files. So how do we do that in Python? Well, first of all, let's open up our file using the open function. We're going to have to put in the name of the file. So we're going to put in this test_file.txt, but your file may vary. We're going to open it using read mode. Then we're going to say that a new variable called text is going to be file.read. Then we're going to print text, and then we're going to close our file. Now, that went pretty quickly. So what we're doing is we're opening our file, we're storing it inside a variable called file. Then we're accessing our file. We're using the read function. This is going to return a string, and we're going to store that in a text variable. We're going to call it text. Then we're going to print text, and then it's good practice to close the file, not to hog up memory. So let's see what the output of that is. It should print out the text. Again, this is what is stored inside of our file. So let's run this and see what happens. And as you can see, it prints exactly what we told it to. But what if we want to print just one line at a time? Then similarly, we can open our file again and put in our mode, which is read. Then what we want to do is we want to create the text variable, although maybe we should call it text line, since we're only going to be accessing one line of the text. And there's a separate function called read line. So we're opening our file, and then we're saying that the text line is going to be equal to the function read line applied to file. So this should read a line from file, the first line, and return it as a string. And we're going to store it in this variable text line. Let's run that, and then let's create a new block of code. We're going to print text line and see what we get. And what we get is the first line, hello everyone, which as we can see is the first line in our text file. So now let's see what happens if we run that again. Let's say text line is equal to file.read line. And this is going to give us the next line. So if we run this and then we print text line, we should get the next line, which is, this is a test file made for testing purposes. And that's exactly what it says here. Awesome. So why didn't we just print our file? Let's see what happens if we try to do that. First of all, let's close our file. And now let's open up a new file. It should be the same file as before. Test file.txt. And then our mode, which is read. Then what we want to do is print file. And let's see what we get. Oh, we get an error. Because this here isn't a string, this is an object which is storing our file, all of the information about our file. So if we want to read the text inside, we need to first convert it into a string. And that's what the read and the read line functions are for. If you try to use the read line function after you've already finished reading the last line in your text file, it will return nothing. Okay, so let's say we want to write to a file. How do we do that in Python? Let's create a new code block. And what we need to do is first open our file, aka use the open function, and we need to give it a name. Let's call it new_file, and we need to add the extension .txt. And this is where it gets interesting, because now we use the write mode instead of the read mode. Now that we have our file, we can write to it. So what we do is we access the file variable where it's stored, and we use the .write function. We use the write method, and then we can write some text inside, like hello world, for example. Then we can run that, and we've successfully created a file. Let's see what that looks like. And this is what's written inside our new file, hello world, which, as you can see, is exactly what we passed through in here. So that's pretty cool. And if we want, we can write as many things in here as we want. So for example, let's write how are you? Then we can also write in the next line, I'm fine, thanks. And if we run that, and as you can see, the new things that we wrote down are now stored inside of the file. So now we have to close our file. But what if we don't want to have to close it every single time? What if we want to tell the program to do that for us so that we don't have to do it? Well, there's an easy way to do that using the with statement. So using the with statement, we can basically create an indented section of code within which the open function will operate, and once it's finished, it will close automatically. So basically, just to put it in layman's terms, we're saying everything that goes inside this with area is going to terminate as soon as it's finished. We can say with, and we can use the open function. Then let's say test file.txt. We'll put in the mode, read, and then we give it a file name. So let's say test file, and this will be the variable that we access the file with. And then we'll say test file dot read line, and we'll print that as well. What this should do is it should open the test file with the read mode using the open function, create a variable called test file, and store the result of the open function into the test file, and then it should read the first line from that test file. Finally, it should close everything and open up our memory. So let's see what happens. What we should expect is that we see the first line of our test file that we created earlier. Let's see. As you can see, the text from our test file from the first line appears, so we can see that it worked. Okay everybody, so that was the video on file input output. It was a fairly quick one, and to be honest with you, it's something that's quite simple, but it can be explored quite deeply. There's a lot of things that I didn't show you in this video that you can find on the internet, because the amount of stuff that you can do with file management is crazy. There are so many things that you can do with it.
Hello and welcome to aorbtech. Today we're going to discuss continuous series of the Python Learn to Python series, and in this session we're going to discuss briefly object-oriented programming part 1. The agenda of today's session: first we will briefly discuss how we can create class, then we will see object, after that we'll see some attributes such as class and instance, and then we will see self-parameter and statistic method, and in the last we will see a very important concept, which is constructor. So let's start. Before moving to a class, let's see the definition of object-oriented programming. Solving a problem by creating an object is one of the most popular approach in programming. If I see the definition, OOP is a way of coding where you make things in your program act like real life things. For example, a car, known its color and speed, it can be drive or stop. So that's the example of object-oriented program. Now we'll see class. A class is basically a template. You can also call a blueprint for making object. If I give the example of a class, a car will be our class, and then we will write some method. Don't worry, I'll explain the method later in this video. Just assume that method is basically a function. So we write a function inside class. One can be a speed, second can be a color, then it can also be some function such as drive or stop. So let's create a class. Just wanted to show you. Let's say that we create a class name will be a car. For now I'm just passing, not writing anything. We'll write the example later after seeing the definition of object. then I will give you full example. So this is how we can create a class. Just write class and then whatever name you want to write of the class, and then you filling by writing methods and so on. So if I give another example, let's say that I wanted to class and I wanted to say that school, just pass it for now. So this is how we can create a class. Now we'll move forward with the next topic, which is object. After that we will see a proper example of class and object. Now we'll see object. An object is a real things you create from a class. If I explain more better way, object is basically initiation of a class, which means once the class is defined, template is defined, memory allocated only after object initiation. So if I give the example of car, a car is a blueprint, a red Toyota is the object. Now we will create a class. So class, the name of the class is car. After that we write a method of a class, and let's say that I wanted to give the name of the method is just name, and then I will pass self. Don't worry, I'll explain self later. Just need to understand how we can create a class and initiation of object after creating a class. So let's say I wanted to print, I want to use a string for that, and I wanted to say that car name is, and then I would say that self dot name. So now what I did here I create a class, and then I define a method inside class, and I gave the name of the method is name. Self, don't worry, I will explain later. Now then what I'm doing here, basically I wanted to create object and I wanted to fill some object. Let's say that now I'm going to initiation of my class. Let's say that I wanted to say the name car name should be, I'm defining my class here, so the C is capital here, and then now I am filling my object, and let's say the car name dot car is equal to Toyota, and if I print car name dot car, it will show my Toyota. Now I'll explain how it's work. What I did here, first I create a class. After that I write a method. You can write a multiple method, for example name, function of the car, color, etc, etc. So I write a one method here, and the name of my method is name, and then I wanted to print basically car name. So here if you see the code, you can see clearly I basically define a proper template here. So my class template is ready. After that what I am doing here, basically I'm initiation of my class, which is object, and then I filling the memory what I write here in the class. So I write car name, which is basically car, then I just recall my name like method name, and then I write Toyota, and simply I print it. So what I get, Toyota. If I wanted to say for example another name, let's say I wanted to say BMW, I don't need to initialization class every time. So if I say BMW and if I print it, I will get BMW. So what happened here, I can fill the object with the different values because my template is defined here. So this is how you can create a class here. So you can also write a multiple method. For example, let me give the same example, and then I wanted to write the method which could be, let me write from scratch. So let's say that I wanted to write the method name is color, and I wanted to print the color value as well. So now we have, I just write, now I have to initialize my object. Let's say that car name, and let's say I just write car, or maybe I just write the simply car model, I would say that. And now I just recall the name and method. I just wanted to print the name. Also I want to print the model of the color. Something happened here. What's the error? Car model name. Sorry, I just have to be, don't need this parenthesis, not really showing my name. Perfect. Okay, so what I did here, I create a class. I write a two method. One method is basically representing the name of the car, and the second method is basically representing a color. I already defined a template. In the template, you can fill the value by initiation class. So you can write any name of the car, you can write any color of the car. So what I did here, first I initialize my class. So this is basically, this initiation of a class is basically object. This is a definition of object. Now what I'm doing here, I am basically calling my first method and filling the object with the value of BMW. After that, I'm calling my second method and I'm filling the value with the black, and after I'm just printing the value. So as you can see, that BMW and black. So this is how you can create a class, which means you can make your own class. Take any real life example, for example airline booking, transportation, or for example job application, or anything else. Then you can write the method and you just basically filling the object in this template, and that's how it's work. So I hope it's understand for you. Now we'll see a two important concept. The first one is class attribute and the second one is object attribute. So these are two most important concepts that we use in class and object. So let's see. Now we'll see a two most important concept that we used most common in object and class. The first one is basically we discuss now is class attribute. After that we will discuss object attribute as well. So what is the definition of class attribute? Class attribute is basically attribute that belongs to a class rather than object. So it's basically directly associated with the class. So if I show you with the code example, so is, let's say that I wanted to write a class and class name is car. Now I wanted to create a class attribute, and let's say that my name of class attribute is BMW, let's say that. So now I'm initiation of my object and it's called C, and I want to print my class attribute and it will return BMW big. And what I am doing here, I basically what I'm doing here, I'm basically create a class and then I write a class attribute which is BMW, and after that I just initiation of my class and then I printing my class attribute, so which return me a BMW. I can create another class attribute, for example color, I would say that black, and I can print another attribute of a class which is color, so it will return me BMW and black, as you can see. So if I want to change the name of class attribute, how you can do that? So I would say class, and then I call my name of the car, just take one example here, and then I say that car name is equal to car, and now I wanted to change my class attribute. How I can do that? So simply I can say that car name dot name is equal to Toyota, and then I print it, and something happened which is anyway. So as you can see here, I change my class attribute. So if I explain what I'm doing here, I create a class. The name of the class is car, and then after initiation of class object, what I did here, I just change my class attribute name. So car name dot car, replace BMW with Toyota, and simply I print it. So this is how class attribute is work. Now we'll move to a next topic, which is object attribute. Now we'll see what is object attributes. Previously we see the class attribute, we also see a few example of class attribute. So object attribute is basically belong to a object rather than class itself. So if I give you example here, and I wanted to say class which is car, and then let's say that I create a name of the car is basically BMW. Now I'm going to initiation of my class. Let's say that car1 is equal to car, and then I print my value of my value of class, and I get my BMW. Now what I am trying to do here, this is example of class. So now I wanted to create my object attribute. How I can do that? So let me remove this one. So car1 dot color is equal to black, and now I wanted to print my object attribute. So print car1 dot color, I will get black. So what I did here, I create object attribute which is basically black. So this is my class attribute. This is basically a object attribute. It's not belong to my class attribute itself, but it's belong to my object attribute itself. So if you can see, this one is basically linked with the class attribute, but this one is not. This is separately, and this is basically object attribute. So the next concept that I'm going to explain is self parameter. And self parameter is nothing but it's just object itself. It lets object use its own data and own function. If I give you example of car as a class name, then self dot color, which mean that my color. So let me show you with example. Let's say that I wanted to write a class, and class name is basically car. Now what I'm doing here, I'm going to write a one method, and I'm going to write the method name is color. Then I'm passing self parameter, but also taking one parameter, which is let's say that color. After that, I'm going to pass my object, which is self.color, and then I wanted to print my car color. So how I can do that? So let me initialize my object, and I'm going to write car1 is car, and I wanted to fill the value with the object is, let's say that brown. And now I wanted to run this program, and as you can see that car color is brown. So this is how object is worked. As I said that if a color say that self dot color, which mean that my color, car color in this example. For so hope it's clear for you. Maybe one question for you, maybe you can use other name instead of self. So let's try. Should same, instead of self I say that slf and slf. Will this work or not? Yes, it will definitely work. You can call any name instead of self. So this is how you can write and define a self inside method and calling the object name as well. So I hope this concept will clear for you. So next we're going to see what is static method. A static method in Python is a method inside a class. So if I see the properties, the first property, we do not use self or a class while writing static method. First thing. The second thing, we are writing a function inside class, normal function, as we write without class, for example. So for that we just need to mention underscore static method, and then we just write a normal function. And last and very important thing, it belongs to a class, not to any one object. So let me show you an example. Let's say that I wanted to write my class, and my class name is basically a car. Oh sorry, it's markdown. I have to do in the coding. So let's say I wanted to write my car, and then as I said that writing a static method, first you need to define. So you just write underscore and then static method. Now I wanted to write my color, or maybe name, sorry. and I just wanted to write name and I wanted to print it. And if I go down, I just have to finish my class car1 is equal to car, and then car1 dot name print, and what will happen, it will print my car name BMW. So as you can see that we write here a static method and we didn't use any self parameter inside the function, the first property. The second property, as I mentioned, that it's work like a normal function. As you can see, this is a normal function without adding a self parameter stuff. And for that, as I mentioned, that you need to write a static method in start, and then whatever function you write, it will be look like a normal function. And last important thing, it's belong to a class, not to object. So this is how a static method is work. So maybe I can give you another example, and I say that class and I wanted to say calculator. Let's say that calculator, and I'm writing my static method. I just write, don't need for adding method, I just need only add here, and now I'm going to print my results. If I print my the sum of the result is this one. Okay, so here I show you another example, and I create another class which is calculator. Then I'm using my static method. In static method I am adding one function, and this function is what's doing here is basically taking parameters and return after sum up. So I just initialize my class. This is basically object. After that I'm passing my parameter, which means I'm filling object in the class template itself, and then I am printing my values. So the sum is 15. So this is how a static method is work. Next we're going to discuss constructor. It's a very important concept to use in class and object. A constructor is basically a special method. It's run automatically when you create object first property. The second, it always has a self parameter as a first, and then plus some other parameter based on your program. So let me show you the example. Let me say that I wanted to write a class, and class name is car. Now I wanted to take my first method, which is basically a constructor. So I write my constructor. So the way of writing is basically you have to write a 2 underscore init 2 underscore and then parentheses. As I mentioned, it will take first parameter as a self and plus other parameter based on your program requirement. Here I just wanted to print my car name, that's why I use one parameter. You can use other parameter, for example color, speed, or whatever. So let me show you. So if I say that car dot one, set that one, and I wanted to say that if I run, it will say that car name is Toyota. So simply is run as soon as the object is initialized. So as you can see the output here. Simply writing the constructor, you just have to write again to underscore init to underscore, and this is basically how you write your constructor. And this is basically used most of the programmer using a constructor and some other method. Let me show you a proper example. Let's say that I wanted to write a car, and then I said that self parameter, and then I make, and then I wanted to say display of the value and so on. Okay, so let me print and then I will explain how it's work. Okay, so what I am doing here, first basically I write a class, and the class name is basically a car. After that I'm writing a constructor here, and then I'm taking a 3 parameter. One is make, second is model, and the years. After that I'm just initialize my name of those parameter, and then I write my another method, and method name is basically display all the information that I put here in the subject initiation. So basically I just write make Toyota, name of the car, then model is basically Corolla, and then year is 2020. And after that I'm just simply display the results while print car1.display info, which is this one, and I just using f string here, and I'm going to return my results. So this is how I write constructor here. So you can take a multiple example here. For example, I take a class and I wanted to university, then I pass some parameter name, for example department, university name, or maybe the specific object, and after that I am using different method, department functions, program subject function, and so on. So this is, you can make your own program and write based on your problem statement. I hope this concept is clear for you, and we're going to end of these sessions here. And just wanted to mention that this is like a continuous series of object-oriented programming, and the part 2 will also came about the next topic will be inheritance, polymorphism, which is most important topic that we used in object-oriented programming. So I hope everything is clear for you. We are covered following topic. As you can see, a class, object, then we see attributes for the class and object, then we see self parameter, static method, and the last we see a constructor.
Hello and welcome to another installment in the Learn to Pi series. Today we're going to be looking at inheritance and more. We'll be looking over inheritance, overriding, types of inheritance, super method, class method decorator, property decorators, operator overloading, dunder/magic methods. So what is inheritance? Inheritance is essentially when we have a parent class that we create and we want another class that we create to have the same methods and properties as it does. We can then modify this class as we choose, including but not limited to changing those behaviors that we created in the original class and all the properties, and even creating new ones or sometimes removing some features. So there's a lot to do here. Let's look at an example of how inheritance works in Python. Let's look at an example of how inheritance works in Python. First of all, let's create a class. We'll call it food. Then what we want to do is we want to pass, because we won't do anything yet. And then we're going to create another class called apple, which, using parentheses, we can create as a child class of food. This means that we're inheriting everything inside of food, and we're implicitly putting it inside apple without having to explicitly type those things ourselves. Now let's say you want to do something a little bit more interesting. So what we're going to do is we're going to go inside of food and we're going to create a method, and we're going to call it name. Inside of name, we're going to print the name of the item, which in this case is food, and we're not going to do anything inside of apple. So what we've done so far is we've just added a method to food, and apple is the same as it was prior, so nothing interesting going on there. Now let's create two variables, two objects. What we're going to do is we're going to take food, and we're going to create one of those, and then we're going to take the apple and create one of those as well. Now, let's see what the name of food is, our food object that we created, f. It should print food. Now, let's say I wanted to see the name of the a object that I created. I did not ever, as you can see, we have not created a method inside of apple called food. But what I can do, because apple inherits from food, is I can use that method inside of apple. So let's run it and see what happens. And we get food. Now let's say we want to change this behavior inside of apple. Using the same example, let's then go into apple. Let's create the method name. And since we're creating a new method inside with the same name, what we're doing is overriding this method. That means that we're still taking it from the food class, the parent class, but we're changing the way that it works. So if you were to call this method from the food class or from the food object that you create of that class, then it'll act differently when we override it in the child class than it would have previously. So let's see what this looks like in action. Basically, we're going to change the behavior of apple to not print food, but to print apple, because that is the name of the food. So let's once again check what happens if we print the name of the food. It still prints out food. Now let's print out the name of our apple object that we created and see if it differs in any way. And don't forget to put self inside. And as you can see, it has printed apple, which is different to what we did prior. Now we'll be looking at the three different types of inheritance: single, multiple, and multi-level. Single inheritance is an example of the inheritance that we've been looking at so far. It's when we have a parent class and the child class takes all of those methods and all of those properties inside of the parent class and it uses them itself. So let's create a class here. Let's call it school. And let's pass. And now let's create another class and we'll call it room. And we'll say that each school has a room inside of it. And so this inherits from school. And once again, we'll pass. And so what we've created here is a parent-child relationship. We've created a classroom that inherits all of its features from school. Within single inheritance, we can not only override different methods and properties, but we can also add things to the class. So for example, if we wanted to track the number of students, we can add a property within room that is not within the school to track that. Let's say that's equal to 5. Now, what happens when we create a school? Let's call it S. And let's see how many students are in the school. We actually get an error because school is the parent class of room, which means that everything inside school gets placed inside of room, but it does not work in the opposite direction, which means that if we create something in the child class, it doesn't necessarily make its way back to the parent class. But let's say if we created a room, and now if we try to get the number of students, it prints 5. So we can also add things to classes from the parent class to the child class. We can add things in the child class that were not in the parent class as well. Not only overriding, but also adding things. Multiple inheritance is a type of inheritance in which the child class inherits from 2 or more classes, which means that it can have properties and methods from not just one class, but a second one too, or even a third or more. So let's say we want to see what this looks like in action. What we can do is we can create a code block here. Let's create a class called chicken. And inside of this class, we'll have a method called lay egg. and we're going to print egg has been laid, or laid. Now we're going to create a second class called duck, and inside of this class we're going to put another method called quack, and we're going to print quack. And finally we're going to create another class called turkey, and inside of this class we're going to create a method called spread tail, inside of this method we're going to print tail has been spread. Now what we can actually do is we can create another class called duckin, and it's going to inherit from chicken, duck, and turkey, all inside parentheses. And so now all of these methods that we have in each of these different classes have been passed onto this class over here, this child class called turducken. So what we can do is we can create a property, for example, called name, and it's going to be turducken. So it's a sort of mixture of the three, and we're not going to change anything else about it. Now what we can do is we can create a turducken, and we can use the methods that are in all the parent classes without any issue. So we can use all of these methods, and we can also check its name. So everything that was in all of these previous classes, these parent classes, has been passed onto this class, this child class. And we've also added a new property to this class that isn't in any of the previous classes. And so let's see what happens when we run this. So as you can see, all of these work, and then we also get the additional variable that we added, the property. So what we can also do in here is we can even override one of the previous methods. So let's recreate quack. Maybe it quacks in a different way than a duck would, for example. Maybe it says quonk, for example. And we're going to print quonk. And now, this time, let's run it one more time and see what happens. So as you can see, everything functions the same way except for the method that we changed. Instead of saying quack this time, it said quonk. So that's how multiple inheritance works. Pretty cool. Finally, we have multi-level inheritance. What happens in multi-level inheritance is that you have a class A, for example, which inherits from a class B, which inherits from a class C, and so on. Essentially, you're creating more than two layers. You have a class which inherits from another class which inherits from another class. And what ends up happening is that the first class, which has the first layer, the top layer, which has all of those methods and properties, well, those get passed down to the child class, which can add or override those. And then that also gets passed down to the final child, for example. And in this case, we would have the base class, which is the one at the top layer that I was describing. We have the intermediary class or classes. There may be more in the middle. It's sort of like a sandwich if you think about it. And finally, at the end of the sandwich, we have the derived class, the bottom bun if you think about it in that way. And that is in what inherits from all the previous classes. But if there are any changes made along the way, then it will not inherit the original versions of those properties or methods, but it will instead inherit those changes. So keep that in mind. Let's see what that looks like in practice. We can create a class called grandfather. Inside that class, we're going to pass. Then we can create another class called father, which inherits from grandfather. And we're going to pass. Finally, we're going to create a class called child, which inherits from father. Then we're going to pass once again. Now everything that was inside grandfather gets put into father, which can then be remixed, changed, added to, or some other thing done to it. And then that gets passed down to child, which can then do whatever it wishes with that information or that data. Now what I've done here is I've given each of these people a name. Let's say we want to create a method in the grandfather class. We're going to call it name or say name. And what the grandfather returns is very straightforward. He just returns his name. Let's print that. Now, the father, he has a different way of doing things. Throughout his life, he's realized that it's a bit too difficult to say Patrick. So what he does is instead, he says Pat. And now the child is very young. So what he says, when he tries to say his name, is goo goo ga ga, because he's a baby, let's say. Now, what we can do is we can create a grandfather, we can create a father, and we can create a son, or a child. And let's say we want each of these to say their names. So say name, then we'll go on to the father, and then let's go on to the child. And let's see what happens. So as you can see, they all have different things inside of them, even though they inherit from each other. Now let's say that the grandfather has something universal. Let's say he has a family heirloom. And let's say it's called, let's say it's a hairpin, or perhaps it's a ball. If now I wanted to access, for example, the father's family heirloom, it would be the exact same as the grandfather's. And it would be the same if I did it with the child. He would still inherit what was in the father's class, and he would inherit from what was in the grandfather's class. So as you can see, things are passed down, so to speak, through the generations. Let's talk about the super method. What the super method allows us to do is it allows us to access information from the parent class of the current class, or in our case the child class. To make this look simple, I've created a class literally called parent, and then a child class literally called child, which inherits from its parent. Now if we try to print the age of the child, first of all let's create a child here, and let's print its age. You can see that we get the actual age of the child. Now let's say for some reason we can't create a parent class, but we still want to access the information inside it. What are we to do? What we can do is we create a method here called parent age. And we can create super age. And now what happens when we get c dot parent age? Oh, and we've got to return that, of course. Now we get 32, which is the parent's age. Very cool. Now let's say we want to change something inside of the class, like a method or property, during the runtime of the program, without changing the code beforehand. To do this, we use a class method decorator. To demonstrate this, I've created a scenario. First, I'm creating a class person, and within it, I'm creating a property age, which is set to 25 by default. Then I'm creating a method called changeAge, which allows us to change the age of the object. Next, I'm creating an object called Jerry, and then I'm printing Jerry's age. I'm going to try to change the age of Jerry using the change age method that I created. Then I'm going to print Jerry's age, and finally we're going to compare it against the person class's age. Let's see what happens. As you can see, it starts out as 25. When we print Jerry's age, we also get 25 because we didn't change his age. Then when we use the change age method, Jerry's age changes to 20. And if we compare it against the class, it has remained the same. Now let's try using the class method decorator. What this is going to do, and it's going to tell the class that if we create an object and we use this function, we don't want to change the value of the property in the object. We want to change the value of the property in the class. Now let's see how our values change. Remember, we currently have 25, 20, and then 25 again. So we made Jerry younger, basically. Let's see what happens now. So what we tried to do is we created a person, Jerry. Let's see what his age is from the beginning. It's 25. Then we're going to change Jerry's age, and we're going to print Jerry's age. And as you can see, we get 20. Finally, we're going to print the person class's age, and we get 20 as well. So not only did Jerry's age change, but the age of the class also changed. In programming, when we want to control the type of data that another programmer has access to in our classes, or even that we have access to in our classes, we use get and set methods. These allow us to access variables without changing them, or change variables without accessing them necessarily. This is useful when we want to limit the control that people have to our objects or classes in programming, and we can see how to do that here in Python with getters and setters. To see how that works, we start by creating a class. Let's call it goat. This goat is going to have an age. We're going to create a method now with the decorator property. This is what allows us to define this as a get method. Let's say we want to access the current age of the goat. So we're going to create a method for that. We're going to return age, or the age of the goat. Now, let's create a goat. And now let's print its age. There we go. And we get its current age. Now let's see what happens when we try to change this age to something a little bit different. Like, let's say we wanted to make this an 18-year-old goat so it could access certain sites on the internet that it should not be able to access. As you can see, we get an error because we're not allowed to do that. This is specifically for getting information, not for setting it or changing it. So that's what we're doing by using this over here. To demonstrate how setter works, I've created a class called dialog. Inside this class, I've created a property called Derek. I've then created a accused name get method and a accused name set method. And the way that you create one of these is by using the decorator with the name of the property dot setter added to the end of it. And you have to make sure that this is the same as the property decorator created before, the get decorator. Now I've created a method in here called accuse, and what this will do is it'll print this value here, this property, and some other text. So let's see how this works. I've created here D for dialog, a little object, and I'm gonna use the accuse method, see what happens. As you can see, it prints Derek is responsible because that's the default value for the property that we created here. Let's say I want to change this property without accessing d.accused. I want to use specifically accused name. So let's say the accused name is going to be Elizabeth. And now what we should see is that without ever calling accused or ever using d.accused, we will actually be able to change the variable using this setter over here. So Derek is responsible should change to Elizabeth is responsible. Let's see what happens. As you can see, that's exactly what changed. Let's say we create an object or a class in which we want to use the operators such as plus, minus, modulus, any of the above, and lots of more. Well, To allow us to change the behavior of the class to apply these operators between different objects that we create, we can use operator overloading. To show how this works, we're going to create a class. We're going to call it number. Inside, we're going to create a constructor. And we're going to take in a variable called num, and we're going to assign that to itself. And then we're going to create another method, and that's going to be add. And this is where the magic happens. So we're going to take self and then another num2. But this is not going to be a number, this is going to be an object actually. This is going to be the second object that we're adding. So what we're going to do is, let's say we want to print something, just to change the behavior up a little bit. Let's make an f string, let's say adding, and then we'll show, this number as well. And then we're going to return the sum of both our numbers, so self.num and num2.num. Remember that num2 is not, in fact, the second number itself, like an integer, it is the second object, so we need to access num within that. Now, let's say we create two numbers, a and b. Let's say that a is 7 and b is equal to 42. Using our class here, so we created two objects. And now let's store the sum by adding a and b. And let's print that and see what happens. So, before we run this code, what we should expect is that because we're using this method here, it's going to actually print that we're adding these two numbers. And then, once we get it returned, we're then going to print that here. We're going to display that. So what we should get is adding 7 and 42, and then we should see the result of that. So let's see what happens. Oh, and here we go. Of course, we need to return the sum. So let's see what happens here. As you can see, 49. We get the sum. So remember not to accidentally create one of these. You need to actually have the sum there. Although this is what happens when you use the add operator, it doesn't necessarily need to be the sum. For example, we could use minus here just as easily, and we would get something completely different. We could even use the multiplication operator. This is just what happens when we use this operator in between these two objects here. It doesn't need to be adding, but we will probably make it that way specifically for this example. So there you see 49. Awesome. Okay, so let's look at some other magic methods, starting with str. What str does is it allows us to create a string representation of an object. So let's say we have a class. Let's call it person. Let's create a constructor really quickly. Let's pass in self, and let's give him a name, and let's give him, yeah, seems fair. Let's make sure we do that properly. Then we'll say that the name is equal to whatever we pass in that. And now let's create an str. Let's pass in self. And what we should do is return self.name. Now let's create a person. Let's call him Ben. And let's see what happens when we try to print the object. So what happens when we try to print an object is we get this str method here. This basically returns a string representation of the object for us to see. So hopefully what we should see, the result is that it prints Ben. Oh, that's what we get. Perfect. The next magic method is len. And what this does is it basically returns the length representation of an object, if you can call it that. So let's say we wanted to use the method or the function length or len on our object. What would it return? Well, that's what we're going to define now. So let's create that. Here, let's pass in self. And in this version of person, I've initialized it with height instead of name. So we're going to return self.height. There we go. Now let's create a person. And let's say that this person is 170 centimeters tall. And so now we're going to get the length of this person. It should return the length in some way. Let's say the person is lying down, so we're measuring their length. And let's see what we get. Oh, we get their height. The final magic method is the rep_r method. What this allows us to do is give a string representation of all of the arguments necessary to create a clone of our object using the constructor. So let's say here I have a class person with a name and a surname. I have a string representation so we can check what it looks like. And then I have a rep_r function that returns a comma separated list, comma and space separated list of our different arguments here. So let's print what George looks like. His name is George Baker. Let's create a perfect clone of George by creating someone called B. We'll use the person class. And inside, we're going to use the rep_r method with our object, with George inside. We're going to split it using comma and a space, and then we're going to unpack that using an asterisk. It's a little bit complicated, but then what we get when we print B is this. Make sure to put that in the right place, and hopefully we should get my name is George Baker twice. There you go, and that's how you use the rep_r method. And that's the end of the Learn to Pi series. I really hope you guys enjoyed this. This was a labor of love. It took us lots of time and effort to set this up for you guys. I really hope that you enjoy it and that you learned a lot from it. As usual, we have lots of other socials. We have a GitHub with all of the code that we did in this episode and all the episodes prior available in the description, as well as the website and all of our socials. If you enjoyed this video and series, make sure to like and subscribe and hit that bell icon if you want to see more like this. And stay tuned because we're going to be coming out with our NumPy series, as well as a number of other series related to programming and computer science and data science and all those things. So if you're interested, again, make sure to hit that bell icon, subscribe, like, share with a friend if you want to give them the gift of programming and data science and learning. And hopefully I'll see you in the next series. So, bye-bye.